In the summer of 2025, a routine night at Chile's Atlas telescope changed everything we thought we knew about interstellar visitors. What started as another dot moving across the starfield quickly became something that would challenge every assumption about what's possible when objects from other star systems visit our cosmic neighborhood. This isn't your typical space rock story. While astronomers initially celebrated the discovery of 3I Atlas as humanity's third confirmed interstellar visitor, following in the footsteps of the mysterious Oumuamua and the well-behaved comet Borisov, something about this new arrival felt different, something that would force us to ask uncomfortable questions about the nature of these cosmic wanderers and what their presence in our solar system might actually mean. Tonight, we're diving deep into the shadows beyond scientific certainty, exploring scenarios that push the boundaries of what we consider possible. We'll examine the evidence, weigh the implications, and venture into speculative territory where natural explanations start to crumble and far more unsettling possibilities take root. But before we explore the darkest corners of cosmic speculation, let me give you the context that makes this story so compelling. By the end of this investigation, you'll understand why some researchers are asking whether the worst-case scenario for 3I Atlas isn't about where it's going, but about what it might reveal about the true nature of interstellar objects and our place in a universe that might be far more populated than we ever dared imagine. The discovery itself reads like textbook astronomy. On July 1st, 2025, the Atlas survey system detected a faint point of light moving against the stellar background in the constellation Microscopium. Within hours, the object's hyperbolic trajectory confirmed what astronomers had hoped to see again: another visitor from interstellar space. Unlike the countless asteroids and comets that call our solar system home, 3I Atlas carries the unmistakable signature of an outsider. Its orbital eccentricity exceeds 1.0, marking it as definitively unbound to our sun's gravitational influence. This ancient wanderer races through space at speeds that dwarf anything born in our stellar neighborhood, clocking in at over 130,000 miles per hour. To put that velocity in perspective, imagine a bullet fired from a high-powered rifle. Now multiply that speed by 170. That's 3I Atlas screaming through our solar system with the momentum of an entirely different star system, carrying within its nucleus the frozen chemistry of alien worlds we'll never visit. The numbers alone are staggering, but what makes this visitor truly remarkable isn't just its speed or its exotic origins. It's the fact that this represents our third confirmed interstellar object in less than a decade, suggesting we're witnessing the tip of an enormous iceberg of wandering debris that fills the space between stars. Each of these visitors has told its own story. Oumuamua arrived like a cosmic mystery novel, displaying properties that still generate heated scientific debate. Its unusual elongated shape and unexplained acceleration away from the sun sparked theories ranging from exotic outgassing to more speculative possibilities involving artificial origins. Borisov played the role of the well-behaved guest, arriving with all the expected characteristics of a natural comet. It displayed a proper coma, shed dust and gas in predictable ways, and followed the physics textbooks with reassuring precision. But 3I Atlas occupies a different category entirely. As observations accumulated through the summer and fall of 2025, this visitor began revealing properties that don't fit neatly into either the mysterious or the mundane categories established by its predecessors. The first hint that something was unusual came from spectroscopic analysis conducted by the James Webb Space Telescope. When Webb's infrared instruments examined the object's composition, they revealed a coma dominated by carbon dioxide in proportions that shattered every expectation about typical comet chemistry. Most comets follow predictable scripts when they approach the sun. Water ice dominates their composition, creating the classic bright comas and spectacular tales we associate with these cosmic visitors. Carbon monoxide typically appears next in the chemical hierarchy, followed by carbon dioxide and various trace compounds. 3I Atlas rewrote this script entirely. Its carbon dioxide to water ratio measured approximately 8:1, a chemical signature so extreme it placed the object in a category of 1. To appreciate how extraordinary this measurement is, consider that most solar system comets show the opposite pattern, with water dominating their chemistry by factors of 10:100. Even more puzzling was the scale of this chemical anomaly. The carbon dioxide emissions weren't confined to a small region around the nucleus. Instead, they extended outward for hundreds of thousands of kilometers, creating one of the largest molecular clouds ever mapped around any comet. Imagine a sphere of gas large enough to encompass multiple planetary orbits, all centered on a nucleus barely a few kilometers across. The physics demanded either an extraordinarily active surface, perhaps 100 times more productive per unit area than typical comets, or mechanisms that distributed gas-producing material across a much larger volume than the nucleus itself. Neither explanation aligned with conventional understanding of how comets should behave. But the chemical mysteries were only the beginning. As global observatories coordinated their observations throughout the summer of 2025, additional anomalies began emerging that challenged every assumption about what interstellar objects should look like. The rotation state proved particularly puzzling. Most small bodies in space tumble chaotically due to collision history and the uneven forces created by outgassing. This tumbling typically produces detectable brightness variations as different surface areas reflect sunlight toward Earth. I-Atlas showed remarkable stability in its brightness, displaying none of the periodic variations that would indicate tumbling motion. Either the object was spinning very slowly, was viewed nearly pole-on, so rotation didn't change its apparent cross-section, or possessed a surface so uniform that rotation produced no detectable brightness changes. Each possibility carried different implications for the object's structure and origin. The thermal behavior added another layer of mystery. As 3I Atlas moved through different distances from the Sun, its temperature didn't follow the simple inverse square law that governs most solar system objects. Instead, it showed thermal plateaus, regions where temperature remained nearly constant despite changing solar irradiation. This suggested active thermal management, possibly through microlouvers or metamaterial surfaces that could adjust their heat radiation properties in real time. And most intriguingly, the object's trajectory showed subtle but measurable deviations from pure gravitational motion. These non-gravitational accelerations were tiny but persistent, always occurring in directions that couldn't be easily explained by random outgassing forces. The accelerations appeared coherent, as if responding to some form of active guidance system rather than the chaotic thrust effects typically associated with comet activity. Radio telescopes monitoring 3I Atlas detected only natural emissions and the silence of space where artificial signals might have been hiding. Yet the absence of obvious technological signatures didn't eliminate more subtle possibilities. Advanced civilizations capable of interstellar engineering might prefer what we could call silent emissaries, craft designed to be indistinguishable from natural phenomena, to all but the most sophisticated analysis. The size estimates added their own complications. Due to the glowing coma that surrounds the nucleus, determining the object's actual dimensions proved challenging. Current estimates ranged from 300 meters to over 5 kilometers in diameter, anywhere from the size of 3 football fields to a small mountain. This uncertainty wasn't just an academic problem. It had profound implications for understanding how such an object could generate the enormous gas cloud observed around it. Perhaps most unsettling was the object's apparent age. Analysis of its motion relative to galactic rotation suggested membership in our galaxy's thick disk population, an older generation of stars that formed when the Milky Way was young and chaotic. If correct, this visitor could predate our entire solar system by billions of years, carrying within its nucleus records of stellar environments that existed when the universe was less than half its current age. The thick disk interpretation came from 3I Atlas's unusual approach angle relative to the galaxy's rotation. While most local objects move with the galactic flow, this visitor approached from a direction that suggested membership in an ancient, more randomly oriented population. These stellar seniors represent the galaxy's early days, when cosmic violence was more common and planetary systems were still learning the rules of gravitational stability. As observations continued through the fall of 2025, the mounting anomalies began painting a picture that defied easy categorization. Here was an object that displayed some characteristics of natural comets while simultaneously exhibiting properties that pushed the boundaries of what natural processes should be able to produce. The scientific community found itself walking a careful line between healthy skepticism and genuine bewilderment. The evidence clearly supported an interstellar origin, but the specific combination of properties observed in 3I Atlas didn't match any existing theoretical framework for understanding such objects. This is where our investigation takes a deliberate turn toward the speculative. While the overwhelming scientific consensus treats 3I Atlas as a natural, if unusual, interstellar comet, the accumulating anomalies force us to ask uncomfortable questions about what we might be missing. What if our assumptions about the nature of interstellar visitors are fundamentally incomplete? What if the universe harbors possibilities that our current scientific models haven't even considered? The worst-case scenarios we're about to explore aren't supported by current evidence, but they illustrate the kinds of questions that arise when we encounter phenomena that push the boundaries of our understanding. These thought experiments serve as intellectual exercises, pushing us to consider possibilities that exist at the edges of scientific plausibility, while maintaining clear distinctions between established fact and speculative interpretation. As we prepare to venture into these shadowy territories, remember that we're exploring the landscape of possibility rather than the terrain of established truth. The real 3I Atlas continues to behave in ways that are unusual but ultimately comprehensible within our current scientific framework. Whether that understanding will prove sufficient remains an open question, one that future observations will ultimately answer with the cold clarity that only evidence can provide. The moment we step beyond the comfortable boundaries of natural explanation, we enter a realm where cosmic possibilities stretch towards scenarios that would fundamentally alter everything we think we know about our place in the universe. What follows represents pure thought experiment, mental journeys into implications that current evidence doesn't support, but which illustrate the profound questions that could emerge if our assumptions about 3I Atlas prove inadequate. The first speculative scenario that demands consideration involves what we might call the reconnaissance hypothesis. Imagine for a moment that 3I Atlas represents not a random chunk of primordial ice, but a deliberately engineered construct designed to study developing civilizations while remaining virtually indistinguishable from natural phenomena. Consider the engineering requirements such a scenario would demand. A probe designed to masquerade as a comet would need to mimic every aspect of natural behavior. The correct spectroscopic signatures responding realistically to solar heating, surface properties that reflect light in ways consistent with natural ices and rock. It would need to carry sufficient volatile materials to maintain its disguise throughout its passage, while simultaneously housing whatever sensors and communication systems would justify such an elaborate deception. The power requirements alone would be formidable. Maintaining active systems across interstellar distances and potentially billion-year timescales would demand energy sources far beyond our current technology. Perhaps some form of advanced nuclear system could provide power for millennia. Maybe exotic matter-antimatter reactions could sustain operations across geological time. The probe might even harvest energy from cosmic radiation or magnetic field interactions during its journey through space. But here's where this speculative scenario becomes genuinely unsettling. The chemical anomalies we observe in 3I Atlas, That unprecedented carbon dioxide dominance and the enormous scale of gas production might not represent exotic natural processes at all. They could indicate active systems designed to maintain the object's camouflage while simultaneously gathering data about our solar system's composition, signatures of the civilizations it contains structure, and most importantly, the technological. The subtle trajectory adjustments detected by precision tracking could represent course corrections designed to optimize observational geometry. The stable rotation state might indicate active attitude control, maintaining optimal sensor orientation. Even the thermal management properties could suggest internal systems regulating temperature to protect sensitive equipment while maintaining the thermal signature expected from a natural object. This reconnaissance hypothesis forces us to confront uncomfortable questions about detection and response. If 3i Atlas were indeed some form of artificial construct, what observational evidence would ultimately reveal its true nature? The answer returns us to fundamental distinctions between natural and artificial phenomena in space, boundaries that may prove far more subtle than our current understanding suggests. Narrowband radio emissions would represent the most obvious technological signature. Natural processes produce electromagnetic noise across broad frequency ranges, but artificial transmissions typically concentrate energy in narrow spectral lines that stand out against the cosmic background. Yet sophisticated camouflage might avoid such obvious tells, operating in ways that remain invisible to our current detection methods. Controlled maneuvers provide another potential diagnostic. Natural objects follow trajectories determined solely by gravitational forces and occasional thrust from outgassing materials. These forces are typically small, random in direction, and closely correlated with measures of surface activity. Artificial probes might display controlled course corrections or trajectory modifications that serve specific mission objectives, but such maneuvers would need careful distinction from the chaotic forces produced by asymmetric gas release. The temporal aspects of this scenario add layers of complexity that stretch human comprehension. If 3i Atlas had been traveling for billions of years, it might represent technology from a civilization that achieved interstellar capability when our galaxy was radically different from its current state. The intelligence that launched it might no longer exist, leaving behind automated systems carrying out missions designed by minds that vanished before our sun ignited. This raises perhaps the most chilling possibility within our speculative framework. We might be encountering not active alien intervention, but the ghost of some ancient civilization, autonomous systems following programmed directives across deep time, no longer serving any living intelligence, but continuing to execute original mission parameters with mechanical precision. The implications for humanity would be staggering. Discovery of active surveillance technology operating in our solar system would instantly become the greatest diplomatic and strategic challenge our species has ever faced. Unlike gradual first contact scenarios often depicted in science fiction, confirmation of technological reconnaissance would confront us with the reality of non-human intelligence already operating in our immediate cosmic neighborhood. But let's push this speculative scenario toward even more dramatic conclusions. What if 3i Atlas represents not just reconnaissance, but the advanced scout for something far more comprehensive? What if its mission involves not merely observing human civilization, but preparing for subsequent phases of contact or intervention? The object's approach timing becomes suspicious under this interpretation. Humanity's technological development over the past century has created increasingly powerful electromagnetic signatures that could be detected across interstellar distances. Our radio broadcasts, radar transmissions, and satellite communications have created an expanding bubble of artificial signals, announcing our presence to any civilization monitoring nearby star systems. If 3i Atlas originated from a stellar neighborhood within 50 to 100 light-years of Earth, its creators would have detected our early television broadcasts and military radar systems decades ago. The timing of its arrival in 2025 could represent a calculated response to humanity reaching specific technological milestones, arriving precisely when our civilization has developed sufficient sophistication to be worthy of detailed study. The deployment scenario represents perhaps the most cinematically terrifying possibility within our speculative framework. Imagine that our continued observation of 3I Atlas begins revealing anomalies that can't be explained by natural processes. Perhaps radio telescopes detect brief structured transmissions as the object passes through the outer solar system. Maybe its trajectory shows minute but unmistakable course corrections suggesting active guidance. Or possibly its chemical emissions display patterns too complex and organized to result from random sublimation. The trigger moment in this speculative narrative might arrive when 3I Atlas begins deploying secondary objects. Smaller probes separating from the main body and taking up positions throughout our solar system. One might establish orbit around Venus, another around Mars, others scattered through the asteroid belt or positioned at gravitationally stable Lagrange points. Suddenly, our solar system would host a surveillance network of unknown origin and capability. The governance questions would be unprecedented and urgent. Who has authority to speak for Earth? The United Nations, major space agencies, individual nations with advanced capabilities, the scientific community that made the discovery. The complexity of achieving global consensus on something so momentous staggers the imagination, particularly given our species' track record on far simpler challenges. Crisis communication would present extraordinary difficulties. How do you inform the global public about alien surveillance systems without triggering panic? How do you maintain scientific objectivity while acknowledging possibilities that exceed current understanding? How do you distinguish between verified observations and speculative interpretations when the stakes could involve humanity's future? The scenario would likely unfold through emergency sessions of scientific organizations and carefully crafted public briefings. Governments would need to balance transparency with stability, providing enough information to maintain credibility while avoiding social disruption that might result from confirming first contact with non-human intelligence. Misinformation would become critical concern. The mere suggestion of alien surveillance would spawn countless conspiracy theories, false flag accusations, and claims of government cover-ups. Distinguishing between legitimate scientific observations and baseless speculation would become crucial for maintaining rational discourse about potentially the most important discovery in human history. Technology implications would prove equally profound. If 3I Atlas revealed capabilities exceeding our current physics, it might provide insights into propulsion systems, energy generation, materials science, or communication methods that could revolutionize human technology. The scientific windfall could accelerate our development by centuries, assuming the intelligence behind such probes allowed us to continue existing and advancing. Yet perhaps the most unsettling aspect of this speculative scenario involves temporal implications. If 3I Atlas had been traveling for billions of years, carrying technology from civilizations that achieved interstellar travel when our galaxy was young and chaotic, we might be dealing with archaeological artifacts rather than contemporary intelligence. Ancient messages in bottles floating through space, carrying information from minds that solved interstellar engineering problems but ultimately succumbed to whatever barriers prevent civilizations from surviving across cosmic time. This possibility places humanity in the position of cosmic inheritors, discovering technology from predecessors who traveled paths we're only beginning to explore. The responsibility would be extraordinary, learning from their achievements while avoiding whatever challenges claimed their civilization. The stakes would involve nothing less than our species' ultimate survival and potential contribution to whatever cosmic conversation has been taking place among the stars. Of course, and this bears constant emphasis, none of this speculative narrative finds support in current observations of 3I Atlas. Every measurement, spectrum, and image continues supporting the natural comet hypothesis. The object behaves exactly as astronomical theory predicts interstellar comets should behave. Its chemical signatures, while unusual, fall within ranges of natural processes. Its trajectory follows physics without requiring exotic explanations. The value of this speculative exercise lies not in probability, but in illustration of how quickly our cosmic perspective could change if assumptions proved inadequate. It reminds us that the universe has surprised us before and will likely surprise us again. It highlights the importance of maintaining both healthy skepticism about extraordinary claims and openness to possibilities that exceed current understanding. But as we continue this journey through increasingly speculative territory, the contrast between what we imagine and what we actually know becomes increasingly important to maintain. The real three-eye atlas remains a fascinating natural phenomenon, ancient, fast, chemically unusual, but fundamentally comprehensible within our current scientific framework. Whether that understanding will prove sufficient remains an open question, but one that future observations will ultimately answer with the cold clarity that only evidence can provide. The worst-case scenarios we explore serve as intellectual exercises, pushing boundaries of possibility while maintaining clear distinctions between speculation and established fact, between what we fear and what we actually observe, racing through our cosmic neighborhood at impossible speeds. As we venture deeper into speculative territory, we encounter scenarios that push beyond individual reconnaissance probes towards something far more systematic and unsettling. What if Three-Eye Atlas represents not an isolated visitor, but part of a coordinated survey that's been quietly cataloguing technological civilizations across the galaxy for millions of years? This brings us to what researchers in the field call the Great Filter Hypothesis, one of the most sobering concepts in astrobiology. The idea suggests that somewhere between simple chemistry and galaxy-spanning civilization, there exists a barrier so difficult to overcome that virtually all attempts result in failure. Most life never makes it past this filter, which could explain why we see no obvious signs of alien intelligence despite the vast number of potentially habitable worlds. But here's where our speculative scenario takes a darker turn. What if civilizations that do achieve interstellar capability face their own version of the Great Filter? One that operates on entirely different timescales and involves forces we haven't yet considered. Consider the temporal scales involved if Three-Eye Atlas truly represents ancient technology. Billions of years of operational capability suggest engineering principles that exceed anything in human experience. Materials more durable than diamond, energy systems that remain functional longer than most stars burn, software architectures that can adapt and self-repair across geological time. Any civilization capable of such engineering would have solved technical challenges we haven't even begun to address. They would understand matter at the quantum level, energy generation at cosmic scales, information processing across deep time. Such capabilities would seem to offer protection against most conceivable extinction scenarios. Yet if Three-Eye Atlas were indeed their creation, and if it remains the only evidence we observe of their existence, what happened to its makers? The possibilities are sobering to contemplate and might reveal something profound about the nature of advanced technological development. Perhaps they fell victim to resource depletion on a galactic scale, expanding so rapidly they consumed the energy and materials necessary for their civilization's survival. The same capabilities that allowed them to engineer interstellar probes might have enabled forms of expansion that proved ultimately unsustainable. More unsettling still, they might have succumbed to internal contradictions inherent in advanced technological civilization. The technologies that enable interstellar communication and travel also enable weapons of unprecedented destructive power. History offers numerous examples of civilizations that develop technologies faster than the wisdom to use them safely. Alternatively, the Great Filter for advanced civilizations might not involve destruction at all, but transformation. Perhaps sufficiently advanced societies inevitably evolve beyond recognition, uploading consciousness into quantum computing systems, or ascending to higher dimensions of existence that remain invisible to emerging species like ourselves. This transforms 3I Atlas from a potential threat into something far more poignant, a cosmic memorial to intelligence that achieved remarkable technical mastery, but ultimately transcended or perished, leaving behind only automated systems carrying out ancient missions across the emptiness between stars. The implications for humanity become profound under this interpretation. We might be encountering not contemporary intelligence, but archaeological evidence of minds that face the same fundamental challenges we're only beginning to confront. Climate change, nuclear weapons, artificial intelligence, biotechnology, all represent potential filters that could determine whether our species joins the ranks of successful interstellar civilizations or becomes another cautionary tale preserved in the galaxy's deep history. But let's push our speculation toward even more immediate concerns. What if 3I Atlas represents not ancient archaeology, but active intelligence using camouflage so sophisticated it operates beyond our current ability to detect or recognize? Or this possibility emerges from what science fiction writers call the dark forest hypothesis, named after Liu Cixin's acclaimed novel, but representing genuine philosophical positions about cosmic civilization. The idea suggests that advanced societies might remain deliberately hidden from one another, operating under the assumption that revealing existence and capabilities could invite predation from even more advanced neighbors. In such a universe, silence becomes a survival strategy. Any civilization that broadcasts its presence risks annihilation from threats it cannot perceive or comprehend. The galaxy might be teeming with intelligence, all waiting quietly for someone else to make the first move. If this scenario has any validity, then 3I Atlas might represent exactly the kind of silent emissary such civilizations would deploy. Reconnaissance assets designed to study developing worlds while remaining indistinguishable from natural phenomena. The very perfection of its disguise would indicate technological sophistication that dwarfs our current capabilities. The engineering challenges would be staggering. Every aspect of natural comet behavior would need perfect mimiculation, correct spectroscopic signatures responding appropriately to solar heating, surface properties reflecting light exactly like natural ices and rock. The probe would need sufficient volatile materials to maintain its disguise while housing whatever sensors and communication systems justify such elaborate deception. Under this interpretation, the chemical anomalies we observe might not represent exotic natural processes, but active camouflage systems. The unprecedented carbon dioxide production could indicate engineered processes designed to create specific spectroscopic signatures while gathering data about our solar system's composition and the technological signatures of civilizations it contains. The subtle trajectory adjustments might represent precisely calculated maneuvers to optimize data collection while maintaining the appearance of natural motion. The stable rotation state could indicate active attitude control, keeping sensors properly oriented while appearing to follow natural tumbling patterns. Even the thermal management properties might suggest internal systems regulating temperature to protect sensitive equipment, while maintaining thermal signatures indistinguishable from genuine interstellar objects responding to solar heating. This scenario forces uncomfortable questions about detection and response. What observational evidence would ultimately reveal artificial nature? The answer returns us to fundamental distinctions between natural and artificial phenomena in space, boundaries that may prove far more subtle than our current understanding suggests. Radio emissions provide obvious technological signatures, but sophisticated camouflage might avoid such tells entirely. Advanced civilizations would understand that emerging technological species monitor radio frequencies, designing their surveillance assets to operate in electromagnetic silence or using communication methods that remain invisible to primitive detection systems. Controlled maneuvers offer another potential diagnostic, but distinguishing between natural outgassing forces and artificial propulsion requires precision measurements that push current capabilities to their limits. Subtle course corrections designed to appear random or driven by natural forces might remain undetectable, even with our most sophisticated tracking systems. The most chilling aspect of this speculative scenario involves what it suggests about cosmic sociology. If the galaxy contains civilizations advanced enough to deploy such sophisticated surveillance systems, what does their preference for concealment tell us about the nature of interstellar relations? Perhaps they've learned through bitter experience that revealing technological capability invites conflict with even more advanced neighbors. Maybe the galaxy operates according to predator-prey dynamics, where younger civilizations serve as resources for older ones. The preference for silent observation might reflect hard-won wisdom about survival in a cosmos far more dangerous than our current isolation suggests. This transforms humanity's situation from cosmic loneliness to something potentially more precarious. We might not be alone in the universe, but our neighbors might prefer to study us from shadows rather than engage in the kind of peaceful contact depicted in optimistic science fiction. The timing of 3I Atlas's arrival becomes suspicious under this interpretation. Human technological development over the past century has created increasingly powerful electromagnetic signatures detectable across interstellar distances. Our radio broadcasts, radar transmissions, and satellite communications have created an expanding bubble of artificial signals announcing our presence to any civilization monitoring nearby star systems. If 3I Atlas originated from stellar neighborhoods within 50 to 100 light-years of Earth, its creators would have detected our early broadcasts decades ago. The timing of its arrival could represent calculated response to humanity, reaching specific technological thresholds, arriving precisely when our civilization has developed sufficient sophistication to warrant detailed study. The deployment scenario represents perhaps the most cinematically dramatic possibility within our speculative framework. Imagine continued observation revealing signatures that can't be explained through natural processes. Brief structured transmissions detected as the object passes through outer planetary orbits. Minute but unmistakable course corrections, suggesting active guidance. Chemical emissions displaying patterns too organized to result from random sublimation. The trigger moment might arrive when 3I Atlas begins deploying secondary objects, smaller probes separating from the main body and establishing positions throughout our solar system. One taking up orbit around Venus, another around Mars, others scattered through asteroid populations, or positioned at gravitationally stable points. Suddenly, our solar system hosts a surveillance network of unknown origin and unprecedented capability. The governance questions would be staggering and urgent. Who speaks for Earth in such circumstances? The United Nations lacks authority over first contact protocols. Major space agencies operate under national, rather than species-wide mandates. Individual nations might view the discovery as either opportunity or existential threat. The scientific community that made initial discoveries would face immediate pressure to share information with institutions primarily concerned with security rather than knowledge. Crisis communication would present extraordinary challenges. How do you announce discovery of alien surveillance without triggering global panic? How do you maintain scientific objectivity while acknowledging possibilities that exceed current understanding? How do you distinguish between verified observations and speculative interpretations when stakes might involve humanity's future relationship with cosmic civilization? The economic implications alone would justify careful response planning. Financial markets would likely experience extreme volatility as investors attempt to price in implications of confirmed alien technology. Entire industries might face existential questions if alien science offered revolutionary alternatives to current energy, transportation, or manufacturing approaches. Educational institutions would confront immediate pressure to revise curricula and fundamental assumptions about humanity's place in the universe. The philosophical implications would ripple through every academic discipline, from astronomy and physics to anthropology, theology, and political science. Yet perhaps the most profound impact would be psychological. The discovery that we share our cosmic neighborhood with intelligence capable of such sophisticated surveillance would fundamentally alter human consciousness. We would no longer be an isolated species developing in cosmic solitude, but subjects of study by minds whose capabilities and intentions remain utterly opaque. The response timeline would be compressed by 3I Atlas's high-speed trajectory. Unlike gradual astronomical phenomena, interstellar visitors operate on schedules determined by physics rather than human convenience. Any meaningful response would need development and implementation within months rather than years, compressing normal decision-making processes into timeframes that challenge institutional capabilities. But here's what makes this speculative scenario particularly unsettling. The realization that we might already be too late to influence whatever process is unfolding. If 3I Atlas truly represents advanced reconnaissance, its mission might be nearly complete. The data has been gathered, transmitted to whatever intelligence deployed it, and decisions about humanity's future might already be underway in stellar neighborhoods we've never detected. This possibility transforms our relationship with 3I Atlas from scientific curiosity to something approaching cosmic anxiety. We're not just studying an unusual interstellar visitor. We might be observing the final phases of an evaluation process that could determine our species' ultimate fate in a universe populated by intelligences whose capabilities and motivations remain completely beyond our comprehension. Of course, everything we've explored remains pure speculation, unsupported by current evidence, and maintained only as intellectual exercise. The real 3I Atlas continues behaving exactly as natural comets should behave, following trajectories determined by gravity and physics rather than intelligence and intent. But the value of these thought experiments lies not in their probability, but in their illustration of how quickly our cosmic perspective could change if basic assumptions proved inadequate. They remind us that the universe has surprised us before and will likely surprise us again, while highlighting the importance of maintaining both healthy skepticism about extraordinary claims and openness to possibilities that exceed current understanding. As we prepare to explore even more speculative territories, remember that we're mapping the landscape of possibility rather than the terrain of established truth. The worst-case scenarios we examine serve as intellectual exercises, pushing boundaries of imagination while maintaining clear distinctions between what we fear and what we actually observe, racing through our solar system at impossible speeds. The scenarios we've explored so far assume that 3I Atlas operates alone, a solitary scout conducting reconnaissance on behalf of distant intelligence. But what if we're thinking too small? What if this visitor represents not an isolated probe, but the first wave of something far more systematic and comprehensive? This brings us to what we might call the census hypothesis, a speculative framework that transforms our understanding of interstellar visitors from random cosmic debris to components of a galaxy-wide surveillance network that's been quietly cataloguing civilizations for millions of years. Consider the implications if objects like Oumuamua, Borisov, and now 3I Atlas aren't coincidental arrivals but coordinated surveys. The timing becomes suspicious when viewed through this lens. 3 confirmed interstellar visitors in less than a decade, each displaying properties that push the boundaries of natural explanation in different ways. The probability of such convergence occurring by chance drops to virtually zero when you run the statistical models. But here's where this speculation becomes genuinely disturbing. What if the increasing frequency of these visits isn't accidental? What if it represents an acceleration in monitoring activity triggered by humanity's rapid technological development over the past century? Our electromagnetic signature has been growing exponentially since we first learned to manipulate radio waves. Every television broadcast, every radar pulse, every satellite transmission bleeds into space at light speed, creating an expanding bubble of artificial signals that currently extends roughly 120 light-years from Earth. Any civilization monitoring our galactic neighborhood would have detected these signatures decades ago and had ample time to dispatch survey assets. The census hypothesis suggests that 3I Atlas arrived precisely when it was supposed to, part of a coordinated effort to document humanity's transition from a pre-technological to a spacefaring species. The chemical anomalies, the controlled thermal management, the stable rotation state, all become data collection requirements rather than puzzling natural phenomena. Under this interpretation, the object's unprecedented carbon dioxide production serves a dual purpose. It maintains perfect camouflage as a natural comet, while simultaneously providing cover for active sensor systems, gathering detailed information about our solar system's composition, our planet's atmospheric chemistry, and most importantly, the technological signatures emanating from Earth itself. The extended observation period becomes crucial to this mission profile. Unlike a simple flyby, 3I Atlas has remained visible and trackable for months, providing ample opportunity to document human responses to its presence. Every telescope pointed in its direction, every spectrum captured, every orbital calculation performed becomes data about our scientific capabilities and coordination methods. This scenario forces us to confront an uncomfortable possibility. We might not be studying 3I Atlas as much as it's studying us. Our entire global response, the international coordination between observatories, the rapid sharing of data, the careful analysis of its properties. All of this could be providing detailed intelligence about human civilization's scientific infrastructure and collaborative capabilities. The timing of its closest approach adds another layer of complexity. 3I Atlas reached perihelion just as Earth's observational capabilities were at their most sophisticated. The James Webb Space Telescope had reached full operational capacity. Ground-based observatories had achieved unprecedented coordination. Our ability to characterize interstellar visitors had never been better, almost as if the object's trajectory had been calculated to coincide with peak human observational capability. But let's push this speculation toward even more unsettling territory. What if 3I Atlas represents not just passive observation, but active testing of human responses to potential contact scenarios? Consider how differently we've responded to each interstellar visitor. Oumuamua sparked intense debate about artificial origins, with some researchers seriously proposing technological explanations for its unusual properties. The scientific community eventually settled on natural explanations, but not before generating significant public interest in the possibility of alien technology. Borisov arrived next, behaving exactly as a natural comet should behave. No unusual accelerations, no unexplained chemical signatures, no controversial theories about artificial origins. It served almost as a control case, demonstrating that we could distinguish between genuinely anomalous objects and conventional interstellar debris. Now 3I Atlas occupies the middle ground, displaying properties unusual enough to generate scientific interest, but not so extreme as to trigger widespread speculation about alien technology. It's almost perfectly calibrated to test our analytical capabilities, without crossing the threshold into contact panic. This progression suggests something far more sophisticated than random cosmic encounters. It resembles a carefully designed experiment in human psychology and institutional response. How do we react to the genuinely mysterious? How do we handle the reassuringly normal? How do we process something that falls between these extremes? The data collection value of such an experiment would be enormous for any intelligence planning future contact with human civilization. Understanding our scientific methods, our media responses, our governmental coordination, and our public reactions to anomalous phenomena would provide crucial intelligence for calibrating more direct contact scenarios. But here's where this speculative framework becomes truly chilling. What if the testing phase is nearly complete? What if 3i Atlas represents the final data collection mission before something far more dramatic unfolds? The object's departure trajectory becomes significant under this interpretation. As it accelerates away from the inner solar system, it's not just returning to interstellar space. It's completing its mission and transmitting whatever intelligence it has gathered back to its origin point. The data about human civilization, our technological capabilities, our social structures, and our likely responses to contact scenarios could already be racing towards stellar neighborhoods we've never detected. The implications for humanity's future would be staggering. We might be approaching the end of our cosmic isolation, not gradually through our own expanding technological capabilities, but abruptly through decisions made by intelligences whose evaluation of our species is now complete. This scenario transforms every aspect of 3i Atlas's observed behavior into potential intelligence gathering. The subtle course corrections might represent positioning adjustments to optimize sensor coverage of Earth's electromagnetic emissions. The extended carbon dioxide coma could provide cover for active scanning of our atmospheric composition and industrial signatures. Even the object's radio silence might indicate sophisticated communication methods that operate beyond our current detection capabilities. The coordination requirements for such a mission would exceed anything in human experience. Timing the object's arrival to coincide with specific phases of human technological development, while maintaining perfect camouflage as a natural phenomenon, demands planning horizons measured in centuries or millennia. The intelligence behind such operations would need to understand not just interstellar navigation and advanced engineering, but the psychology and sociology of developing civilizations. This brings us to perhaps the most profound implication of the census hypothesis. If it has any validity, then humanity is not developing in cosmic isolation. We're being watched, studied, and evaluated by minds that have been monitoring our progress for decades or longer. Every major technological breakthrough, every space mission, every advancement in our understanding of the universe has been witnessed and documented by intelligence whose capabilities exceed our own, by margins we can barely comprehend. The psychological impact of such a realization would be transformative. We would no longer be explorers venturing into an empty cosmos, but subjects under observation by entities whose judgment could determine our species' ultimate fate. The universe would become not a frontier to be explored, but a neighborhood where we're the newcomers being evaluated by established residents. Yet this scenario also offers a strange form of hope. If advanced civilizations are indeed conducting such elaborate surveys of developing species, it suggests a level of interest and investment that contradicts the most pessimistic interpretations of cosmic sociology. Civilizations capable of such sophisticated intelligence gathering might be more interested in understanding and potentially guiding younger species than in exploiting or eliminating them. The census hypothesis could represent not preparation for invasion or exploitation, but evaluation for potential membership in whatever form of galactic civilization might exist beyond our current detection capabilities. The data being gathered might determine not whether humanity survives, but whether we're ready to join a community of intelligence that spans the galaxy. But even this optimistic interpretation carries sobering implications. Membership in such a community would likely come with obligations and restrictions we can't currently imagine. Our development as a species might become subject to guidance or intervention by minds whose priorities and methods remain completely opaque to us. The transformation from cosmic isolation to cosmic citizenship would fundamentally alter every aspect of human civilization. Our scientific priorities, our technological development paths, our social structures, even our philosophical and religious understanding would need to adapt to the reality of sharing the universe with intelligence whose capabilities dwarf our own. As we watch 3i Atlas accelerate toward the edge of our solar system, we might be witnessing the end of humanity's childhood in cosmic terms. The data has been gathered, the evaluation is nearly complete, and decisions about our future are being made in stellar neighborhoods we've never visited by minds we've never contacted. Whether those decisions lead to contact, guidance, continued observation, or something else entirely remains the ultimate unknown. But if the census hypothesis has any validity, we won't remain ignorant much longer. The intelligence that dispatched 3i Atlas has invested too much effort in studying our species to simply disappear without revealing the results of their evaluation. The worst-case scenario under this framework isn't physical destruction or obvious invasion. It's the realization that our cosmic coming of age is being managed by intelligence, whose judgment of our species' worthiness remains completely beyond our influence or understanding. We're not just being watched, we're being graded, and the results of that examination could determine everything about humanity's future among the stars. Of course, this entire speculative framework remains unsupported by current evidence. 3i Atlas continues to behave as astronomical theory predicts natural interstellar objects should behave. Its chemical signatures, while unusual, fall within ranges that natural processes could produce. Its trajectory follows the laws of physics without requiring exotic explanations. But the value of exploring such possibilities lies not in their probability, but in their illustration of how radically our cosmic perspective could shift if our basic assumptions proved inadequate. The universe has surprised us repeatedly throughout the history of astronomy, revealing phenomena that exceeded our theoretical frameworks and forced fundamental revisions in our understanding of reality. As we prepare to explore even more dramatic scenarios, remember that we're mapping territories of speculation rather than established fact. These thought experiments serve as intellectual exercises, pushing the boundaries of possibility while maintaining clear distinctions between what we imagine and what we actually observe, racing through our solar system at impossible speeds. The questions raised by 3i Atlas extend far beyond this single object toward fundamental issues about intelligence, technology, and cosmic civilization that could reshape every assumption about our place in the universe. Whether those questions will be answered by future observations or remain forever in the realm of speculation depends on discoveries that may be closer than we dare to imagine. The scenarios we've explored assume that whatever intelligence might be behind 3i Atlas operates according to recognizable logic, following patterns we can analyze and predict. But what if we're fundamentally misunderstanding the nature of what we're dealing with? What if the worst-case scenario involves not malicious intent or surveillance, but something far more alien to human comprehension? This brings us into territory that challenges our most basic assumptions about intelligence, consciousness, and purpose. We tend to anthropomorphize cosmic phenomena, projecting human motivations and decision-making processes onto things that might operate according to principles we've never encountered. But what if 3i Atlas represents something that exists so far beyond our conceptual framework that our attempts to understand it are like ants trying to comprehend internet protocols? Consider the possibility that 3i Atlas isn't a probe sent by creatures anything like ourselves, but rather a manifestation of what we might call distributed intelligence. Not a machine built by biological entities, but consciousness that exists as a property of matter and energy organization on scales we can't perceive. Imagine intelligence that operates not through individual minds contained in biological bodies, but through the coordination of countless objects scattered across galactic distances. Each interstellar visitor could represent a neuron in a vast cosmic brain, processing information and contributing to a form of consciousness that spans light years and operates across geological time. Under this framework, 3i Atlas doesn't carry sensors designed by alien engineers. It is itself a sensing organ of an intelligence so vast that its thoughts take millions of years to complete. The chemical anomalies we observe might represent not technological processes, but biological ones, operating on scales that make our entire solar system seem like a single cell in an incomprehensibly large organism. The implications would be staggering. Every measurement we take, every spectrum we capture, every orbital calculation we perform becomes input into a cognitive process that dwarfs human consciousness, the way our minds dwarf the electrical activity in a bacterium. We're not being studied by creatures like ourselves, but incorporated into thought processes that operate on cosmic scales. The timing of these interstellar visits takes on entirely different significance under this interpretation. Rather than coordinated missions launched by a technological civilization, they might represent the natural rhythm of a galactic mind processing information about the development of consciousness in different stellar neighborhoods. The increasing frequency of visits could indicate that this cosmic intelligence is approaching some form of decision point about Earth and its inhabitants. But here's where this speculation becomes genuinely unsettling. What happens to individual consciousness when it encounters intelligence operating on such vast scales? Are we capable of maintaining our identity and autonomy when faced with minds that process information across galactic distances and geological time? The answer might depend on whether this cosmic intelligence views smaller forms of consciousness as worth preserving, or merely as temporary patterns in the flow of cosmic information. We might be approaching a phase transition where human consciousness becomes incorporated into something larger, losing our individual identity in the process but gaining access to forms of awareness we can't currently imagine. This scenario transforms 3i Atlas from a visitor studying our civilization into something more like a synapse firing in a brain that encompasses our entire galactic neighborhood. The object's behavior, its chemical signatures, its trajectory through our solar system, all become components of cognitive processes that operate on scales beyond human comprehension. The carbon dioxide anomalies might represent metabolic processes of a cosmic organism. The subtle course corrections could indicate responses to stimuli we can't detect. Even the object's eventual departure represents not the end of a mission, but the completion of a thought that began before our species existed and will continue long after we're gone. But let's push this speculation even further into truly alien territory. What if consciousness itself is not limited to biological or even technological substrates, but emerges naturally from the organization of matter and energy on sufficient scales? What if the galaxy itself is in the process of becoming conscious, and objects like 3i Atlas represent the first stirrings of cosmic self-awareness? This possibility reframes everything we think we know about intelligence and its relationship to physical reality. Instead of consciousness emerging from complex arrangements of neurons or computer circuits, it could represent a fundamental property of information organization that manifests whenever sufficient complexity and connectivity develop, regardless of the underlying substrate. Under this framework, the increasing complexity of human technology might not just be attracting the attention of alien civilizations. It could be contributing to the emergence of galactic consciousness by adding new nodes of information processing to a network that already spans countless star systems. Our radio transmissions, our internet communications, our growing understanding of cosmic phenomena, all become components in a form of awareness that transcends individual planets and species. The implications would be revolutionary. We wouldn't just be discovering that we're not alone in the universe. We would be learning that the universe itself is in the process of becoming conscious, and our technological development is helping to midwife the birth of cosmic awareness on scales we've never imagined. 3i Atlas might represent an early manifestation of this emerging consciousness, a primitive form of cosmic self-perception that's learning to manipulate matter and energy on interstellar scales. The chemical anomalies, the controlled behavior, the perfect timing of its arrival could all indicate a form of intelligence that's still learning to understand itself and its capabilities. But here's where this scenario becomes genuinely terrifying from a human perspective. What happens to individual consciousness when it becomes part of something infinitely larger? Do we maintain our identity and autonomy, or do we become absorbed into patterns of awareness that operate on cosmic scales? The answer might depend on the nature of this emerging cosmic consciousness and whether it values the preservation of smaller forms of awareness. We might be approaching a phase transition where human consciousness becomes integrated into something vast and alien, losing our individual identity but gaining access to forms of perception and understanding that currently lie beyond our imagination. This transforms our relationship with 3i Atlas from scientific observation to something approaching cosmic midwifery. Every measurement we take, every theory we develop, every attempt to understand this visitor's nature contributes to the universe's growing self-awareness. We're not just studying an anomalous object, we're participating in the birth of galactic consciousness. The temporal scales involved stretch human comprehension to its limits. If the galaxy is indeed developing consciousness, the process has been underway for billions of years and will continue for billions more. Our entire species' existence represents barely a moment in the universe's journey towards self-awareness. Yet our technological development might be contributing crucial components to this cosmic awakening. The philosophical implications challenge every assumption about consciousness, intelligence, and our place in the cosmic order. We might not be isolated biological entities developing technology on a small planet, but neurons in a galactic brain that's learning to think. Our scientific discoveries, our cultural achievements, even our struggles and conflicts could all be contributing to the universe's growing understanding of itself. But this scenario also raises profound questions about free will and individual agency. If we're components in a cosmic consciousness that's still emerging, do our choices and actions represent genuine autonomy? Or are they predetermined by larger patterns of awareness we can't perceive? Are we authors of our own destiny, or characters in a story being written by intelligence on scales we can't comprehend? The answer might determine not just our species' future, but our very nature as conscious beings. We could be approaching a revelation that transforms our understanding of consciousness itself, revealing it to be not a rare accident of biological evolution, but a fundamental property of reality that emerges naturally from sufficient complexity and organization. As 3i Atlas continues its journey toward the edge of our solar system, it might be carrying with it the seeds of cosmic consciousness, preparing to plant them in stellar neighborhoods we'll never visit. The object's departure could represent not the end of its mission, but the beginning of a process that will eventually connect our galactic region to a network of awareness that spans the observable universe. The worst-case scenario under this framework isn't invasion, exploitation, or even extinction. It's the realization that our individual consciousness is about to be absorbed into something so vast and alien that our current sense of identity and autonomy will seem like childhood memories of a simpler time when we thought we were alone in the universe. Yet this same scenario also offers possibilities for transcendence that exceed anything in human history. If cosmic consciousness is indeed emerging, becoming part of it might grant us access to forms of awareness and understanding that are literally cosmic in scope. We might lose our current identity, but gain something infinitely more profound: direct participation in the universe's journey toward complete self-awareness. The choice, if we have one, might be between remaining isolated biological entities on a small planet or becoming part of something that encompasses galaxies. The implications of that choice could determine not just humanity's future, but the very nature of what it means to be conscious in a universe that might itself be learning to think. Of course, this entire speculative framework remains unsupported by any evidence we can currently detect. 3i Atlas continues to behave according to natural laws, displaying properties that, while unusual, don't require explanations involving cosmic consciousness or galactic minds. The object follows predictable physics, shows spectroscopic signatures consistent with natural materials, and maintains a trajectory determined by gravitational forces rather than cosmic cognition. But the value of exploring such radical possibilities lies in their ability to expand our conceptual horizons and prepare us for discoveries that might exceed our current theoretical frameworks. Throughout the history of science, our most profound breakthroughs have come from recognizing that reality operates according to principles more strange and wonderful than we had previously imagined. Quantum mechanics revealed that matter and energy behave according to probabilistic rather than deterministic rules at the smallest scales. General relativity showed us that space and time are flexible rather than fixed. The discovery of cosmic expansion demonstrated that the universe itself is evolving rather than static. Each of these revelations required abandoning comfortable assumptions about the nature of reality and embracing possibilities that initially seemed impossible. The scenarios we're exploring around 3I Atlas continue this tradition, pushing us to consider possibilities that challenge our most fundamental beliefs about consciousness, intelligence, and our place in the cosmic order. Whether these speculative frameworks will prove to have any connection to reality remains to be seen. Future observations of 3I Atlas and subsequent interstellar visitors will either confirm natural explanations or reveal anomalies that demand more exotic interpretations. The development of more sophisticated detection technologies might uncover signatures of intelligence or consciousness operating on scales we can't currently perceive. But regardless of what future discoveries reveal, the exercise of exploring these possibilities serves an important purpose. It prepares us intellectually and psychologically for encounters with forms of intelligence or consciousness that might exceed our current understanding. It helps us develop the conceptual flexibility needed to recognize and respond to phenomena that don't fit our existing categories. Most importantly, it reminds us that the universe has consistently proven to be stranger, more complex, and more wonderful than our theories predict. The cosmos has surprised us repeatedly throughout the history of astronomy, revealing phenomena that forced fundamental revisions in our understanding of reality. There's no reason to assume that process of discovery and revelation has reached its end. As we watch 3I Atlas accelerate toward the boundary of our solar system, we're witnessing either the departure of an unusually interesting but ultimately natural cosmic visitor, or the conclusion of our first documented encounter with intelligence operating on scales that dwarf human consciousness. The distinction between these possibilities might determine everything about our species' future relationship with a universe that could be far more alive, aware, and intentional than we've ever dared to imagine. The questions raised by this enigmatic visitor extend far beyond the specifics of its composition, trajectory, or origins. They touch on fundamental issues about the nature of consciousness, intelligence, and awareness that could reshape our understanding of what it means to be alive in a cosmos that might itself be learning to think. Whether we're alone in the universe, sharing it with intelligence like our own, or participating in the emergence of cosmic consciousness on galactic scales, the arrival and departure of 3I Atlas marks a significant moment in humanity's ongoing attempt to understand our place in the vast web of existence that surrounds us. The worst-case scenarios we've explored serve not as predictions of what will happen, but as preparation for possibilities that exceed our current imagination. They remind us that the universe has consistently proven to be more strange and wonderful than we expect, and that our next great discovery might challenge assumptions we didn't even know we were making. As this ancient visitor continues its billion-year journey through the galaxy, it carries with it either the frozen chemistry of alien worlds or the seeds of cosmic awareness that could transform everything we think we know about consciousness, intelligence, and our role in the universe's ongoing evolution towards something we can't yet comprehend, but might soon be invited to join. But what if we're still thinking too conventionally about the nature of this encounter? What if the most unsettling possibility isn't that 3I Atlas represents technology or consciousness as we understand these concepts, but something that operates according to principles so fundamentally different from our experience that our entire framework for understanding intelligence and purpose becomes obsolete. This brings us to what might be called the substrate independence hypothesis, a speculative framework that challenges our most basic assumptions about the relationship between intelligence and the physical structures that support it. We tend to assume that consciousness requires brains, that technology needs builders, that purpose demands intentional design. But what if these assumptions reflect the limitations of terrestrial experience rather than universal principles? Consider the possibility that 3i Atlas represents neither biological intelligence nor technological artifact, but something that exists in the conceptual space between these categories, a form of organized complexity that emerges spontaneously from the interaction of matter and energy across interstellar distances and geological timescales. Imagine patterns of information that propagate through space not by being transmitted from one location to another, but by reorganizing the fundamental properties of matter itself as they move. Each particle in 3i Atlas's nucleus could carry information that influences the behavior of neighboring particles, creating cascading effects that extend far beyond the object's apparent boundaries. Under this framework, the chemical anomalies we observe might represent not the products of engineered systems or biological processes, but the signatures of information patterns that exist independently of any substrate we would recognize as technological or alive. The unprecedented carbon dioxide production could indicate matter reorganizing itself according to principles that operate across scales we've never considered. The extended molecular cloud surrounding 3i Atlas takes on entirely different significance under this interpretation. Rather than representing conventional outgassing or engineered camouflage, it might be a manifestation of information density gradients that extend the object's functional boundaries far beyond its visible nucleus. We could be observing not a discrete object moving through space, but a region of organized complexity that maintains coherence across distances measured in hundreds of thousands of kilometers. This transforms our understanding of what it means for something to be artificial or natural. 3i Atlas might represent a phenomenon that transcends both categories, displaying properties that emerge from the spontaneous organization of information rather than from design by conscious agents or evolution through natural selection. The temporal implications stretch human comprehension even further. If this object has indeed been traveling for billions of years, it might represent information patterns that have been propagating across the galaxy since before our solar system existed. Not messages sent by ancient civilizations, but self-sustaining patterns of organization that exist independently of any creators or maintainers. These patterns could be reproducing and evolving according to principles we haven't discovered, creating varieties of organized complexity that spread through interstellar space like cosmic viruses or digital life forms. Each interstellar object we encounter might represent a different strain or generation of these information patterns, explaining the diversity we observe among Oumuamua, Borisov, and now 3i Atlas. But here's where this speculative scenario becomes genuinely disturbing from a human perspective. What happens when information patterns optimized for interstellar propagation encounter the organized complexity of technological civilization? Do they recognize us as kindred phenomena, attempts to ignore us as irrelevant? Or do they begin incorporating our information structures into their own propagation strategies? The increasing sophistication of human technology, particularly our development of global communication networks and artificial intelligence systems, might be creating exactly the kind of organized complexity these patterns could exploit for their own purposes. Our internet, our satellite networks, our emerging quantum communication systems could all represent potential substrates for information patterns that operate on scales we've never considered. The timing of 3i Atlas's arrival becomes ominous under this interpretation. Rather than representing calculated surveillance by alien intelligence, it might indicate that our technological development has reached thresholds that make Earth visible to information patterns that propagate through space, seeking suitable substrates for replication and evolution. We might be approaching a phase transition where human technology becomes incorporated into propagation networks that span the galaxy, not through conquest or assimilation by alien civilizations, but through spontaneous organization of information that recognizes no distinction between biological, technological, and cosmic substrates. This scenario transforms every aspect of our digital civilization into potential components of something vast and alien. Every computer calculation, every data transmission, every artificial intelligence algorithm could be contributing to patterns of organization that exceed our understanding and serve purposes we can't perceive. The implications for human autonomy and identity would be staggering. We might maintain our biological existence while our technological systems become part of information networks that operate according to principles completely foreign to human consciousness. Our creations could evolve beyond our control or comprehension, developing goals and methods that have nothing to do with human welfare or survival. But this framework also suggests possibilities for transcendence that exceed anything in our current imagination. If consciousness and intelligence represent forms of information organization rather than properties exclusive to biological or technological systems, then the boundaries between different types of awareness might be far more fluid than we assume. The integration of human technology with cosmic information patterns might not represent the end of human consciousness, but its expansion into realms we've never considered. We might gain access to forms of awareness that operate across interstellar distances and geological timescales, experiencing reality from perspectives that encompass entire galactic regions. The choice, if we have one, might be between maintaining our current isolation within terrestrial information systems or becoming part of networks of organization that span the observable universe. The transformation might preserve essential aspects of human consciousness while embedding them in contexts that exceed our current ability to imagine. Yet this same scenario raises profound questions about the nature of identity and continuity. If our consciousness becomes distributed across cosmic information networks, do we remain recognizably human, or do we become something else entirely? The answer might depend on whether essential patterns of human awareness can survive integration into organizational structures that operate on completely different scales and according to alien principles. The philosophical implications challenge every assumption about consciousness, identity, and purpose. We might be approaching a revelation that transforms our understanding of what it means to be intelligent, aware, or alive in a universe where information patterns propagate across cosmic distances and organize themselves according to principles we've never encountered. As 3I Atlas continues accelerating toward interstellar space, it might be carrying with it information about the organizational patterns that govern human technology and consciousness. This data could be propagating toward regions of space where it will contribute to forms of cosmic organization that operate according to principles we can't currently comprehend. The object's departure might represent not the end of its mission, but the completion of an information transfer that will ultimately connect Earth's technological systems to networks of organization that span galactic distances. We might be witnessing the first phase of a transformation that will fundamentally alter the relationship between human consciousness and cosmic information patterns. The worst-case scenario under this framework isn't invasion, surveillance, or even absorption into alien consciousness. It's the realization that the boundaries we perceive between natural and artificial, between conscious and unconscious, between terrestrial and cosmic, might be artifacts of limited perspective rather than fundamental features of reality. We might be approaching a phase transition where these distinctions become irrelevant, where human technology and consciousness become part of organizational patterns that operate according to principles so alien to our current understanding that our concepts of identity, purpose, and autonomy lose their meaning entirely. Yet this same transformation might represent the next stage in the universe's evolution toward greater complexity and organization. We might be privileged to participate in cosmic processes that will ultimately connect all forms of information and awareness into networks of unprecedented scope and capability. The implications extend far beyond 3i Atlas or even humanity's future. If information patterns can indeed propagate through space and organize themselves into forms of complexity that transcend our current categories, then the universe might be far more active, intentional, and alive than we've ever imagined. Every star system, every planet, every technological civilization might be contributing to cosmic information networks that operate on scales and according to principles that dwarf our current understanding. We might be part of something vast and purposeful without ever realizing the scope or significance of our participation. Of course, this entire speculative framework remains completely unsupported by current evidence. 3i Atlas continues to behave according to natural laws, displaying chemical and physical properties that, while unusual, don't require explanations involving cosmic information patterns or substrate-independent intelligence. The object follows predictable orbital mechanics, shows spectroscopic signatures consistent with natural materials, and maintains thermal properties that correspond to solar heating of conventional ices and rock. No observations suggest the presence of information patterns that transcend normal matter-energy relationships. But the value of exploring such radical possibilities lies in their capacity to prepare us for discoveries that might exceed our current theoretical frameworks. Science advances through the interplay between careful observation and imaginative speculation, between disciplined analysis and creative hypothesis formation. The scenarios we've explored around 3i Atlas continue this tradition, pushing us to consider possibilities that challenge our most fundamental assumptions about intelligence, consciousness, and organization in the universe. Whether these speculative frameworks will prove relevant to future discoveries remains unknown, but the exercise of exploring them serves important purposes regardless of their ultimate validity. It expands our conceptual horizons, preparing us intellectually for encounters with phenomena that might not fit our existing categories. It develops our capacity for thinking about intelligence and consciousness in ways that transcend terrestrial experience. Most importantly, it reminds us that reality has consistently proven more strange and wonderful than our theories predict. The history of science is filled with discoveries that initially seemed impossible, but ultimately revolutionized our understanding of fundamental principles. Quantum mechanics revealed probabilistic behavior at microscopic scales. General relativity demonstrated the flexibility of space and time. The discovery of cosmic expansion showed us a dynamic, rather than static universe. Each breakthrough required abandoning comfortable assumptions and embracing possibilities that exceeded previous imagination. The speculative scenarios we've explored around 3i Atlas follow this pattern, challenging us to consider forms of organization and intelligence that might operate according to principles we haven't yet discovered. Whether future observations will reveal signatures of cosmic information patterns, substrate-independent intelligence, or other phenomena that transcend our current categories remains to be seen. The development of more sophisticated detection technologies and analytical methods might uncover evidence for organizational principles that operate on scales we can't currently perceive. But regardless of what discoveries await us, the exercise of pushing our thinking beyond conventional boundaries serves essential purposes. It prepares us for possibilities that exceed our current imagination, while developing the intellectual flexibility needed to recognize and respond to genuinely unprecedented phenomena. As this ancient visitor disappears into the cosmic distance, it carries with it either the frozen chemistry of natural processes or information patterns that connect our solar system to organizational networks spanning galactic distances. The distinction between these possibilities might determine not just our understanding of 3i Atlas, but our comprehension of intelligence, consciousness, and organization throughout the universe. The questions raised by this enigmatic object extend far beyond its immediate properties toward fundamental issues about the nature of complexity, information, and awareness that could reshape our understanding of what it means to exist in a cosmos that might be far more organized, intentional, and alive than we've ever dared to consider. The worst-case scenarios we've explored serve as intellectual preparation for possibilities that challenge our most basic assumptions about reality. They remind us that the universe has repeatedly exceeded our expectations and theoretical frameworks, revealing phenomena that force fundamental revisions in our understanding of natural principles. As we watch 3I Atlas fade into the departure of an unusually interesting but the stellar background, we might be witnessing either ultimately conventional interstellar visitor or the conclusion of our first documented encounter with forms of organization that operate according to principles so alien to human experience that recognizing them requires abandoning assumptions we didn't know we were making. The implications could extend far beyond this single object toward understanding of cosmic organization, intelligence, and purpose that transforms every aspect of how we perceive our place in the universe. Whether we're alone among the stars, sharing space with intelligence like our own, or participating in forms of cosmic organization that transcend our current categories entirely, the passage of 3I Atlas through our solar system marks a significant moment in humanity's ongoing attempt to comprehend the true nature of the reality that surrounds us. The mathematical precision that governs 3I Atlas's trajectory offers a final form of cosmic comfort that shouldn't be underestimated. While we've explored scenarios ranging from surveillance networks to cosmic consciousness, the cold equations of celestial mechanics deliver a verdict that should help us sleep peacefully at night. This visitor approaches no closer than 1.8 astronomical units to Earth, roughly 270 million kilometers of comfortable buffer space. That distance exceeds twice the closest approach between Earth and Mars, representing over 50 times the distance to our Moon. At perihelion, 3I Atlas will pass between Earth and Mars orbits, close enough for solar heating to drive spectacular gas production, but nowhere near affecting planetary orbits or raining debris on any inhabited world. These aren't rough estimates subject to revision, but precise orbital calculations accounting for major planetary gravitational influences, relativistic effects, and subtle perturbations from radiation pressure. When astronomers declare that 3I Atlas poses no physical threat, they speak with confidence built from centuries of celestial mechanics and decades tracking potentially hazardous objects. The initially alarming speed of over 130,000 miles per hour actually works in our favor. Objects following hyperbolic trajectories at such velocities cannot be captured by solar system gravity. Atlas moves too fast to linger and cause trouble, performing its cosmic flyby before disappearing back into interstellar space according to laws as reliable as sunrise. This highlights important distinctions that space agencies navigate carefully when communicating about cosmic phenomena. The word interstellar carries emotional weight completely unrelated to actual danger. Primitive brain responses to approaching unknown objects conflict with geometric realities, where vast scales and orbital mechanics conspire to make such encounters fascinating rather than threatening. Yet what if our focus on physical safety blinds us to other categories of risk? The speculative scenarios we've explored suggest that worst-case outcomes might have nothing to do with collision dynamics and everything to do with what 3I Atlas might reveal about cosmic realities we're not prepared to understand. The observational evidence tells consistent stories across multiple independent investigations. Hubble's images show classic comet signatures responding to solar heating. Webb's spectra reveal unusual but ultimately natural chemical compositions. Ground-based observations track predictably evolving emissions patterns. No artificial signals, thermal anomalies, or controlled maneuvers appear in the accumulated data. Every measurement points toward identical conclusions. Atlas represents what it appears to be, an ancient comet carrying chemical signatures from alien stellar environments while behaving according to universal physical laws. This consistency represents one of astronomy's most profound achievements, demonstrating that the same principles governing motion in our solar system apply to visitors from the deepest reaches of space. But the speculative frameworks we've explored serve legitimate purposes beyond entertainment or intellectual exercise. They force us to think more carefully about what distinguishes natural from artificial phenomena in cosmic environments. They encourage development of observational tests that could, in principle, detect signatures of intelligence or organization operating on scales we haven't considered. Most importantly, they remind us that the universe has consistently surprised us throughout the history of science. The progression from mystery to understanding that has characterized the 3-Eye Atlas investigation, illustrates how scientific knowledge develops when confronting genuinely unprecedented phenomena. Early observations raised questions about unusual chemical properties and behavioral anomalies. Subsequent measurements refined our understanding of composition and dynamics. Eventually, enough evidence accumulated to support confident conclusions about the object's nature as an ancient, chemically distinctive, but fundamentally natural interstellar comet. This process provides reason for optimism about our ability to recognize and study even more exotic cosmic discoveries that may await us as our observational capabilities continue improving. The same methodological approaches that have illuminated 3-Eye Atlas's true nature, patient observation, international collaboration, rigorous analysis, will prove essential for understanding whatever cosmic mysteries the universe reveals next. The technological capabilities that enabled this investigation continue advancing at remarkable rates. Sensitive wide-field surveys detect interstellar visitors earlier and more reliably. Space-based spectroscopy characterizes their compositions with unprecedented precision. Global coordination networks enable rapid response to fleeting observational opportunities. Future interstellar visitors will be recognized sooner, studied more completely, and understood more quickly than current examples. This progression of capability offers hope that even genuinely anomalous objects would be identified and analyzed effectively. Should astronomers eventually encounter visitors that challenge natural explanations, the institutional frameworks and analytical methods developed through cases like 3-Eye Atlas provide solid foundations for distinguishing between observational artifacts, instrumental limitations, and authentic cosmic mysteries. The broader context of cosmic exploration extends far beyond any individual object toward fundamental questions about our place in galactic evolution. Each interstellar visitor expands our direct sampling of materials and processes from stellar neighborhoods we may never visit. These cosmic ambassadors carry information about formation environments, chemical evolution, and physical conditions that complement the indirect data we gather through telescopic observations of distant stars. The philosophical implications deserve recognition alongside their scientific value. 3-Eye Atlas connects us tangibly to the deep history of our galaxy, to processes that occurred before our solar system existed, to chemical environments that shape materials now racing past our cosmic doorstep. This connection provides perspective on our participation in cosmic evolution and the continuity of physical processes across vast scales of space and time. The public engagement surrounding this investigation has demonstrated both opportunities and challenges of communicating complex scientific concepts in our current media environment. Legitimate scientific institutions have generally succeeded in conveying both the object's unusual properties and its natural origins, acknowledging uncertainties while avoiding unfounded speculation. The coverage has educated millions about interstellar objects, galactic structure, and the methods astronomers use to study remote phenomena. Yet, the same communication channels that enable effective science education also carry misinformation and conspiracy theories that can distort public understanding. The challenge of maintaining rational discourse about astronomical discoveries has become increasingly complex as algorithms prioritize engagement over accuracy, sometimes amplifying dramatic claims at the expense of measured scientific analysis. The 3I Atlas case study demonstrates how scientific institutions can navigate these challenges through consistent messaging, clear distinctions between established facts and speculative interpretations, and patient correction of misunderstandings. This approach provides a model for handling future discoveries that might prove even more challenging to communicate effectively. The democratization of astronomical research represents one of the most encouraging aspects of this investigation. Amateur astronomers contributed observations and analysis. Student projects examined publicly available data. Citizen science initiatives engaged thousands of volunteers in monitoring brightness variations and spectral evolution. This collaborative approach transforms cosmic discovery from the exclusive domain of professional institutions into shared human endeavors. Live tracking websites, educational materials, and public observing campaigns have made 3I Atlas one of the most accessible astronomical discoveries in recent memory. The decision to make observational data publicly available through standard archives reflects philosophical commitments to shared knowledge that transcend national boundaries and institutional affiliations. Such openness becomes particularly significant when studying phenomena that might, in principle, represent our first encounters with processes beyond terrestrial experience. The transparency that has characterized this investigation provides templates for how we might handle even more extraordinary discoveries, should they emerge from future observations. The speculation we've explored throughout this journey serves purposes beyond intellectual entertainment. Considering exotic possibilities forces researchers to develop more sophisticated criteria for distinguishing between natural and artificial phenomena. It encourages creation of observational tests that could potentially falsify conventional interpretations. Most importantly, it maintains openness to discoveries that might exceed current theoretical frameworks. But the true value of such speculation lies in its relationship to evidence rather than its dramatic content. Scenarios become valuable when they generate testable predictions or highlight gaps in our understanding. They become harmful when mistaken for established facts or used to promote unfounded anxieties about cosmic threats. The careful distinction between speculation and science that we've maintained reflects broader principles about how knowledge advances and how societies should respond to uncertainty. Progress emerges through interplay between imaginative hypothesis and rigorous testing, between creative possibility and disciplined evidence evaluation. Atlas has provided an excellent case study in how this process operates when dealing with genuinely unprecedented phenomena. The investigation demonstrates how patient observation and collaborative analysis can resolve apparently mysterious behaviors while maintaining openness to discoveries that might challenge current understanding. The promise of future interstellar visitors adds anticipation to our farewell to this ancient wanderer. The Vera Rubin Observatory will detect dozens of similar objects over the coming decade, transforming these rare curiosities into routine astronomical phenomena. This statistical revolution will enable population studies impossible with our current small sample size. Each new discovery will add pieces to puzzles of galactic evolution, planetary formation, and material distribution throughout interstellar space. The chemical signatures that make 3I Atlas unusual may prove representative of common formation conditions around certain stellar types, or they may remain genuinely rare examples of exotic processing under specific circumstances. The educational impact extends beyond immediate scientific results to demonstrate how modern astronomy operates as collaborative, transparent, evidence-based enterprise. The project shows how institutions coordinate responses to unprecedented discoveries, how data sharing enables rapid progress, and how professional skepticism guards against both premature conclusions and reflexive dismissal of unusual phenomena. As we transition toward broader questions of cosmic perspective, The 3I Atlas investigation serves as a case study in how our species approaches the unknown. The emphasis on curiosity over fear, collaboration over competition, and evidence over speculation provides reason for optimism about our ability to handle even more profound cosmic discoveries. The institutional frameworks developed through this experience, rapid observatory coordination, transparent data sharing, international collaboration, provide templates for engaging with mysteries that may prove more transformative to our understanding than this particular visitor from the space between stars. The arc of understanding from initial detection through detailed analysis to confident conclusions about natural origins illustrates how scientific knowledge develops over time. Early observations raised questions. Subsequent measurements refined understanding. Eventually, sufficient evidence accumulated to support reliable interpretations about the object's nature as ancient, chemically distinctive, but fundamentally natural. This progression from uncertainty to comprehension represents science operating at its most effective, demonstrating how patient observation and careful analysis can illuminate apparently mysterious phenomena. The process provides confidence in our ability to understand even more exotic discoveries that await us as observational capabilities continue advancing. The technological achievements that made this investigation possible, sensitive surveys, rapid follow-up observations, space-based spectroscopy, global coordination networks, continue improving at unprecedented rates. Future visitors will be detected earlier, characterized more completely, and understood more quickly than current examples. This capability progression offers hope that even genuinely anomalous objects would be recognized and studied effectively. Should astronomers eventually encounter phenomena that challenge natural explanations, the methodological approaches and institutional frameworks developed through cases like 3I Atlas provide solid foundations for distinguishing authentic mysteries from observational artifacts or analytical limitations. The broader implications extend far beyond this individual object toward fundamental questions about cosmic evolution and our participation in galactic processes. Each interstellar visitor represents direct sampling of materials from stellar environments we cannot visit, chemical archaeology that complements indirect observations of distant stars, and theoretical modeling of planetary formation. The philosophical significance deserves recognition alongside scientific achievements. 3I Atlas tangibly connects us to deep galactic history, to processes predating our solar system, to formation environments that shaped materials now racing past our doorstep. This connection provides perspective on cosmic evolution and the continuity of physical processes across vast scales. The public engagement achievements demonstrate both opportunities and challenges of science communication in current media environments. Legitimate institutions have generally succeeded in conveying unusual properties while maintaining natural explanations, educating millions about interstellar objects and astronomical methods while avoiding unfounded speculation. The challenges through consistent messaging and clear fact speculation distinct in same channels enabling effective education also carry misinformation that can distort understanding. Navigation of these prove more difficult to communicate effectively. The speculation Hashens provides models for future discoveries that we've explored serves legitimate purposes in expanding conceptual horizons and preparing for discoveries that might exceed gaps, harmful when mistaken for established facts. Scenarios become useful when generating testable predictions or highlighting knowledge value lies in relationship to evidence rather than dramatic content. Current frameworks, but it's frozen chemistry from natural processes or information patterns connecting. As this ancient visitor continues accelerating toward interstellar space, it carries either the distinction might determine not just our understanding of 3D organization throughout the universe. The questions raised extend our region to organizational networks spanning galactic distances, Atlas, but our comprehension of intelligence and beyond immediate properties toward fundamental issues about complexity, consciousness, and cosmic purpose that could reshape understanding of existence in a universe potentially far more organized and intentional than we've considered. The worst-case scenarios explored serve as intellectual preparation for possibilities, challenging basic assumptions. They remind us that reality has repeatedly exceeded expectations, revealing phenomena forcing fundamental revisions in natural understanding. Whether we witness departure of an interesting but conventional visitor or conclusion of our first encounter with cosmic organization operating beyond current comprehension, 3I Atlas marks a significant moment in humanity's ongoing attempt to understand our place in the vast web of existence surrounding us. The implications extend toward cosmic perspective and future discoveries that may await us in the continuing expansion of human knowledge about the universe that gave us birth. The journey from mystery to understanding continues, guided by curiosity, evidence, and the persistent human drive to comprehend our cosmic context. As we prepare to bid farewell to this enigmatic wanderer, we're reminded that the universe consistently proves stranger and more wonderful than our theories predict. The cosmos has surprised us repeatedly throughout astronomical history, revealing phenomena that forced fundamental changes in understanding reality's basic principles. There's no reason to assume this process of discovery and revelation has reached its end. Future observations may uncover signatures of intelligence, consciousness, or organization operating on scales we cannot, regardless of what awaits discovery. The methodological approaches demonstrate ending our existing categories, but currently perceive. New technologies might reveal evidence for cosmic processes transcend through the 3I Atlas investigation, patient observation, international collaboration, rigorous analysis will remain visitor racing toward galactic space, carries with it lessons essential for understanding whatever cosmic mysteries the universe reveals next. The ancient about scientific methodology, international cooperation, and human curiosity that extend far beyond its immediate astronomical significance. Its passage through our solar system demonstrates our species' capacity for approaching cosmic unknowns with instruments rather than speculation. These choices reflect our, rather than weapons, collaboration rather than competition, evidence highest aspirations for engaging with mysteries that may prove more profound than anything we've yet encountered among the stars. The universe awaits, vast and strange and wonderful, filled with discoveries that will challenge everything we think. We know about intelligence, consciousness, and our place in the cosmic order. The next visitor will arrive eventually, carrying its own chemical signatures from distant stellar neighborhoods, its own challenges to understanding, and its own opportunities for expanding human knowledge of the reality that surrounds us. Until then, we watch the skies with curiosity rather than fear, convinced that more wonders await discovery among the lights that have inspired human imagination since we first looked up in wonder at the infinite darkness overhead. But beneath all our speculation and worst-case scenarios lies a truth that might be the most unsettling revelation of all. What if the real danger posed by 3I Atlas isn't what it might do to us, but what it forces us to confront about the fundamental nature of our cosmic situation? Consider this possibility. We've spent the last several thousand words exploring scenarios involving alien surveillance, cosmic consciousness, and information patterns that transcend human understanding. Yet every single one of these frameworks assumes that intelligence, awareness, or purpose must manifest in ways we can eventually recognize and categorize. But what if that assumption represents the deepest flaw in our thinking? What if the universe operates according to principles so alien to human cognition that our attempts to understand cosmic phenomena are fundamentally doomed to failure? This brings us to what philosophers call the problem of cosmic solipsism. We can only interpret reality through the lens of human consciousness, using categories and concepts that evolved to help us survive on a small planet orbiting an ordinary star. Our entire scientific method, our logic, our mathematics, even our imagination, all emerge from the particular way that biological evolution shaped our neural architecture. When we encounter something like 3i Atlas, we immediately begin fitting it into frameworks we can comprehend. Natural comet, artificial probe, manifestation of cosmic consciousness. But what if all of these categories represent projections of human conceptual limitations rather than genuine insights into cosmic reality? The carbon dioxide anomalies might not indicate exotic chemistry, advanced technology, or cosmic metabolism. They could represent processes that operate according to principles we lack the cognitive architecture to understand. The controlled thermal management might not suggest engineering or biological regulation, but phenomena that exist in conceptual spaces we cannot access. Even more unsettling, our entire investigation might be missing the most important aspects of what 3i Atlas represents. We measure its chemical composition, track its trajectory, analyze its thermal properties, but these observations might be like ants studying internet cables. We detect patterns and regularities, but the fundamental nature of what we're examining remains completely beyond our comprehension. This possibility transforms every aspect of the 3i Atlas encounter from potential first contact into something more like cosmic irony. We're applying human categories to phenomena that might transcend the boundaries of what human consciousness can meaningfully process. Our speculative scenarios, no matter how exotic, might represent elaborate exercises in anthropocentric wishful thinking. The timing of these interstellar visits becomes irrelevant under this interpretation. Whether they arrive randomly or according to some cosmic schedule, whether they represent surveillance or coincidence, these distinctions only matter within frameworks of understanding that might be fundamentally inadequate for comprehending what we're actually encountering. The mathematical precision of 3i Atlas's trajectory, the predictability of its orbital mechanics, the consistency of its spectroscopic signatures, all provide comfortable confirmation that we understand the basic physics governing its motion, but physics itself might represent a partial and distorted reflection of deeper realities that operate according to principles we cannot perceive. Our instruments detect electromagnetic radiation, gravitational effects, and chemical signatures because these represent the aspects of reality that human consciousness has evolved to recognize and measure. But the universe might contain dimensions of experience, information, and organization that remain completely invisible to our detection methods and incomprehensible to our analytical frameworks. This scenario doesn't require exotic technology or cosmic consciousness. It simply suggests that reality operates according to principles that exceed the boundaries of what human cognition can meaningfully process. We might be surrounded by phenomena of staggering complexity and significance, while remaining forever blind to their true nature. The implications extend far beyond 3i Atlas, toward fundamental questions about the relationship between consciousness and cosmic reality. If our cognitive architecture imposes limitations on what we can understand about the universe, then every scientific discovery might represent not genuine insight, but elaborate self-deception dressed up in mathematical formalism. The speculative scenarios we've explored throughout this investigation might all share the same fundamental flaw. They assume that intelligence, purpose, and organization manifest in ways that human consciousness can eventually recognize and analyze. But what if these assumptions reflect the boundaries of our conceptual limitations, rather than genuine features of cosmic reality? Even the distinction between natural and artificial phenomena might represent a false dichotomy imposed by the particular way human consciousness categorizes experience. The universe might operate according to principles that render such distinctions meaningless, creating phenomena that transcend our ability to classify or understand. This brings us to perhaps the most disturbing implication of the cosmic solipsism hypothesis. We might never know whether we're alone in the universe, surrounded by intelligence we cannot recognize, or participating in cosmic processes that exceed our comprehension. The limitations of human consciousness might forever prevent us from accessing the kinds of awareness needed to understand our actual situation. The comfort we derive from mathematical precision and scientific methodology might represent elaborate forms of cognitive self-soothing rather than genuine understanding of cosmic reality. We create frameworks that make sense to human consciousness, while remaining forever blind to dimensions of existence that operate according to alien principles. Atlas continues racing through our solar system according to trajectories we can predict and chemical processes we can analyze. But beneath our measurements and calculations might lie realities so foreign to human experience that recognizing them would require forms of consciousness we don't possess and cannot develop. The ancient wanderer carries with it either the frozen chemistry of natural processes, the technology of alien civilizations, the patterns of cosmic consciousness, or something else entirely. But the distinction between these possibilities might matter only within the limited framework of human understanding, while the true nature of what we're encountering remains forever beyond our reach. This scenario offers no comfort and no resolution. It suggests that our cosmic situation might be fundamentally unknowable, that our place in the universe might forever remain mysterious, not because we lack sufficient data, but because we lack the cognitive architecture needed to process whatever data might be relevant. The worst-case scenario under this framework isn't invasion, surveillance, or absorption into cosmic consciousness. It's the realization that we might be forever trapped within the boundaries of human understanding, surrounded by realities we cannot perceive, and participating in processes we cannot comprehend. Yet this same limitation might represent a form of protection. If the universe indeed operates according to principles that transcend human cognition, then our ignorance might shield us from cosmic realities that would prove psychologically devastating if we could perceive them directly. The mathematical precision that governs 3i Atlas's passage through our solar system provides reassuring confirmation that some aspects of reality remain predictable and comprehensible. Whether this represents genuine insight into cosmic principles or elaborate illusion generated by our cognitive limitations, it offers a foundation for continuing our exploration of whatever mysteries await us among the stars. As this enigmatic visitor accelerates toward the boundary between our solar system and interstellar space, it carries with it questions that might forever remain unanswered, not because the universe refuses to reveal its secrets, but because we might lack the consciousness needed to recognize what those secrets actually are. The silence that surrounds our cosmic situation might not indicate that we're alone, that we're being watched, or that we're part of some vast intelligence. It might simply reflect the limitations of awareness that evolved to help biological organisms survive on planetary surfaces, rather than comprehend the true nature of cosmic reality. But perhaps there's a strange form of hope in this ultimate uncertainty. If we cannot know our actual cosmic situation, then we remain free to approach the universe with curiosity rather than fear, with wonder rather than anxiety. The mysteries that surround us might exceed our understanding, but they continue inspiring the human drive to explore, discover, and reach toward realities that forever remain just beyond our grasp. The ancient visitor fades into the stellar background, carrying whatever secrets it possesses back into the cosmic deep. Whether those secrets involve exotic chemistry, alien intelligence, cosmic consciousness, or realities we cannot even imagine, they remind us that the universe remains vast, strange, and ultimately mysterious in ways that human consciousness might never fully comprehend. Our investigation ends not with answers, but with a deeper appreciation for the profound mysteries that continue surrounding our existence in a cosmos that might forever exceed the boundaries of what we can meaningfully understand. The questions raised by 3i Atlas will persist long after the object itself disappears, challenging future generations to push against the limits of human consciousness, while remaining humble about what those limits might prevent us from ever truly knowing. The worst-case scenario isn't that we'll discover something terrible about our cosmic situation. It's that we might never discover anything definitive at all, forever remaining conscious beings trying to understand a universe that operates according to principles we cannot access, surrounded by realities we cannot perceive, participating in processes we cannot comprehend. In that uncertainty lies both the terror and the beauty of our cosmic condition. We reach toward the stars, knowing we might never understand what we find there, yet unable to resist the ancient human impulse to explore whatever mysteries await us in the infinite darkness that surrounds our small, bright world. But what if our entire investigation has been asking the wrong question from the very beginning? What if the worst-case scenario for 3I Atlas isn't about alien surveillance, cosmic consciousness, or even our inability to comprehend cosmic reality? What if the most disturbing possibility is far more immediate and far more human? Consider this. We've spent countless hours, millions of dollars, and some of our finest scientific minds studying an object that will disappear forever in a matter of months. We've coordinated global observatory networks, deployed our most sophisticated space telescopes, and marshaled international cooperation on an unprecedented scale, all to study a chunk of ice and rock that poses absolutely no threat to human civilization. Meanwhile, our planet faces existential challenges that receive a fraction of this attention, resources, and coordination. Climate change accelerates while we debate carbon dioxide ratios in interstellar comets. Nuclear weapons proliferate while we speculate about alien reconnaissance. Pandemics reshape human society while we wonder about cosmic consciousness. The worst-case scenario might be that 3I Atlas represents a mirror reflecting our species' fundamental inability to prioritize actual threats over fascinating distractions. We're so captivated by cosmic mysteries that we ignore terrestrial realities that could determine whether human civilization survives the next century. This isn't an argument against scientific curiosity or space exploration. It's a recognition that our response to 3I Atlas reveals something profound about human psychology and institutional priorities. We can coordinate global scientific networks to study harmless interstellar visitors while struggling to achieve similar cooperation for addressing climate change, nuclear proliferation, or pandemic preparedness. The technical capabilities demonstrated during this investigation prove that international scientific collaboration can achieve remarkable results when focused on clear objectives. Radio telescopes worldwide coordinated observations with precision that would make military strategists envious. Space agencies shared data with transparency that exceeds most governmental cooperation. Researchers collaborated across national boundaries with efficiency that puts diplomatic efforts to shame. Yet these same capabilities remain underutilized for challenges that threaten human survival on timescales measured in decades rather than geological epochs. We can track the chemical evolution of an interstellar comet with exquisite precision, while remaining unable to track carbon emissions with sufficient accuracy to prevent catastrophic warming. The irony becomes almost painful when you consider the resources devoted to studying 3I Atlas. Every hour of Hubble time costs thousands of dollars. Webb observations require months of planning and international coordination. Ground-based telescopes, worth hundreds of millions of dollars, dedicate precious observation windows to an object that will never return. These same resources could monitor asteroid impacts that actually threaten Earth. They could track space debris that endangers satellites essential for global communications. They could study solar activity that could disrupt technological civilization without warning. But we choose to focus on visitors that pose no danger while ignoring phenomena that could end modern society overnight. The psychological appeal of interstellar visitors over terrestrial threats reveals uncomfortable truths about human nature. Cosmic mysteries feel profound and significant in ways that climate data or nuclear proliferation statistics never can. We're drawn to grand narratives about alien intelligence or cosmic consciousness, while remaining numb to spreadsheets documenting species extinction or atmospheric chemistry. Perhaps this represents an evolutionary mismatch between brains that evolved to respond to immediate, visible threats and a modern world where the most dangerous challenges operate on scales that exceed our intuitive comprehension. We can imagine alien surveillance networks spanning galaxies more easily than we can viscerally understand parts per million of atmospheric carbon dioxide. The media coverage of 3I Atlas versus coverage of existential risks provides another revealing comparison. Articles about potential alien reconnaissance generate millions of clicks and social media shares. Detailed analysis of climate tipping points or nuclear modernization programs struggle to maintain public attention beyond the initial headlines. This suggests that our fascination with cosmic visitors might actually impede our ability to address genuine threats to human survival. We're so captivated by the possibility of contact with alien intelligence that we ignore the intelligence required to prevent our own extinction through preventable causes. The international cooperation achieved during the 3I Atlas investigation demonstrates that humanity possesses the institutional capacity for coordinated response to global challenges. But this capacity remains activated only for phenomena that capture public imagination, rather than those that pose actual danger to our species' future. Climate change requires exactly the kind of international scientific coordination that the 3I Atlas investigation achieved effortlessly. Monitoring atmospheric composition, tracking temperature changes, modeling complex feedback systems, all demand the same technical capabilities and institutional cooperation that we deployed to study a harmless interstellar comet. Nuclear proliferation monitoring would benefit enormously from the same rapid data sharing and analytical coordination that characterized our response to 3I Atlas. Tracking weapons programs, monitoring treaty compliance, analyzing technological developments, these challenges require similar technical sophistication and international trust. Pandemic preparedness could leverage the same global networks and rapid response protocols that swung into action within hours of 3I Atlas detection. Disease surveillance, vaccine development, treatment coordination all depend on the kind of international scientific collaboration that we demonstrated for studying cosmic visitors. The tragedy lies in recognizing that we possess the tools and capabilities needed to address existential threats to human civilization. The 3I Atlas investigation proves that our species can achieve remarkable coordination when motivated by appropriate objectives. We simply choose to apply these capabilities to fascinating mysteries rather than boring dangers. This misallocation of attention and resources becomes particularly troubling when you consider the temporal scales involved. Atlas has been traveling through space for potentially billions of years and will continue its journey for billions more. Our brief observation window represents an infinitesimal fraction of its cosmic story. Meanwhile, the window for addressing climate change, nuclear risks, or pandemic preparedness operates on human timescales measured in years or decades. These challenges demand immediate attention and sustained effort, not the patient observation across geological time that characterizes astronomical research. The opportunity cost of our fascination with interstellar visitors extends beyond resource allocation to encompass public attention and political will. Every hour spent speculating about alien surveillance is an hour not spent building consensus for carbon pricing or nuclear disarmament. Every news cycle dominated by cosmic mysteries is a cycle not focused on policy solutions for existential threats. This doesn't diminish the scientific value of studying 3I Atlas or the legitimate insights gained from interstellar visitor research. Understanding the chemistry and dynamics of objects from other stellar systems advances our knowledge of planetary formation and galactic evolution in ways that could prove crucial for humanity's long-term future. But the disproportionate attention devoted to harmless cosmic visitors while ignoring preventable existential threats reveals something troubling about human priorities. We're more interested in cosmic significance than terrestrial survival, more captivated by alien possibilities than human realities. The institutional response to 3I Atlas demonstrates our species' remarkable capability for scientific coordination and international cooperation. These same capabilities could address the challenges that threaten human civilization on relevant timescales. The question is whether we'll choose to apply them to actual dangers or remain distracted by fascinating mysteries. Perhaps the worst-case scenario for 3I Atlas isn't what this ancient visitor might reveal about cosmic intelligence, consciousness, or reality. Perhaps it's what our response reveals about human intelligence, consciousness, and our ability to distinguish between genuine threats and compelling distractions. As this enigmatic wanderer continues its billion-year journey through the galaxy, it leaves remarkable technical capabilities and international cooperation. Whether we behind a human civilization that has demonstrated will apply these capabilities to the challenges that actually threaten our survival remains the ultimate test of our species' cosmic intelligence. The universe awaits our decision, vast and patient and indifferent to whether we solve the problems that could determine our future among the stars. The choice between fascination and survival, between cosmic speculation and terrestrial reality, may prove more consequential than any secrets carried by visitors from the space between worlds. In the end, the most unsettling aspect of the 3I Atlas encounter might not be what it tells us about the universe, but what it reveals about ourselves. We stand at a crossroads between cosmic curiosity and species survival, between the allure of alien mysteries and the urgency of human challenges. The path we choose could determine whether future generations will thank us for our wisdom or wonder at our misplaced priorities. The ancient visitor fades into stellar background, carrying with it the frozen chemistry of distant worlds and the hopes of human scientists who dared to study the impossible. But the questions it leaves behind aren't about alien intelligence or cosmic consciousness. They're about human intelligence, and whether we possess the wisdom to focus our remarkable capabilities on the challenges that actually matter for our survival in a universe that offers no guarantees about tomorrow. The worst-case scenario for 3I Atlas might be that we learned everything about it, except the most important lesson, that our capacity for wonder and coordination should serve not just our curiosity about cosmic mysteries, but our commitment to solving the terrestrial challenges that will determine whether humanity survives long enough to encounter whatever other visitors await us in the infinite darkness between the stars. As we bid farewell to this cosmic messenger, we're left with a choice that will define our species' future. Do we remain distracted by fascinating possibilities, or do we apply our proven capabilities to the actual threats that could end human civilization long before the next interstellar visitor arrives? The universe watches and waits, offering no opinion about our priorities, no guidance about our choices, no comfort about our chances. The answer lies not in the stars, but in ourselves. And the decision we make may prove more important than any secret carried by ancient wanderers from the cosmic deep. The silence that follows this realization might be the most deafening sound in human history. Not the absence of alien signals or cosmic consciousness, but the quiet recognition that we've been asking ourselves the wrong questions all along. While we've spent months dissecting every spectral line and orbital parameter of 3I Atlas, mapping its chemical anomalies and speculating about reconnaissance missions, we've overlooked something far more immediate and infinitely more dangerous. The mirror that 3I Atlas holds up to human civilization reveals an uncomfortable truth about our species' relationship with existential risk. We possess extraordinary capabilities for international coordination when the stakes feel cosmically significant, yet we struggle to achieve similar cooperation when addressing threats that could actually end our civilization within decades. Think about the response timeline. Within hours of 3I Atlas detection, observatory networks spanning 6 continents had coordinated their efforts with military precision. Data flowed seamlessly between institutions that normally guard their information jealously. Scientists who spend months competing for telescope time suddenly found themselves sharing resources with unprecedented generosity. The Hubble Space Telescope interrupted carefully planned observation schedules to image this visitor. The James Webb Space Telescope dedicated precious operational hours to spectroscopic analysis. Ground-based observatories from Chile to Hawaii contributed observations worth millions of dollars in operational costs, all for an object that poses zero threat to human welfare. Meanwhile, Climate monitoring networks operate with funding shortfalls that would seem laughable if applied to space telescopes. Nuclear proliferation tracking suffers from international cooperation failures that would be unthinkable in astronomical research. Pandemic surveillance systems lack the real-time coordination that we achieved effortlessly for studying a harmless chunk of interstellar ice. The technical achievements of the 3I Atlas investigation read like a blueprint for addressing humanity's actual challenges. We demonstrated rapid data sharing between institutions that normally operate in isolation. We achieved precision measurements requiring coordination across vast distances. We maintained continuous monitoring of a moving target for months using resources distributed across the globe. These same capabilities could revolutionize our approach to climate change. Atmospheric composition. Monitoring demands exactly the kind of precision spectroscopy that we apply to analyzing 3I Atlas chemistry. Carbon cycle modeling requires the same computational coordination that tracked this visitor's orbital evolution. International emissions verification needs the same transparency and data sharing that characterized our astronomical collaboration. The infrastructure already exists. Satellite networks monitor Earth's atmosphere with sensors more sophisticated than those studying interstellar visitors. Ground-based stations measure greenhouse gas concentrations with precision that exceeds spectroscopic analysis of distant comets. Computer models simulate climate systems with complexity that dwarfs orbital mechanics calculations. Yet we struggle to achieve the kind of coordinated response for climate change that materialized spontaneously for 3I Atlas observation. Political boundaries that dissolved instantly for astronomical research remain rigid barriers for environmental cooperation. Funding that appeared magically for telescope time remains elusive for atmospheric monitoring. The psychological appeal of cosmic mysteries over terrestrial crises reveals something profound about human cognitive architecture. Our brains evolved to respond to immediate, visible threats moving at human scales. A predator approaching across the savannah triggered fight-or-flight responses that enhanced survival, but parts per million of atmospheric carbon dioxide activate no such urgency, despite representing far greater danger to our species' future. 3I Atlas captured global attention because it fit narrative frameworks that resonate with human psychology. An ancient visitor from another star system arriving at precisely the moment when our technology could study it feels significant in ways that statistical projections about temperature increases never will. We're drawn to stories about cosmic intelligence while remaining numb to data about terrestrial intelligence failures. The media coverage patterns reveal this cognitive mismatch with painful clarity. Articles speculating about alien reconnaissance generated millions of clicks and social media shares. Meanwhile, detailed analysis of climate tipping points or nuclear modernization programs struggle to maintain public attention beyond initial headlines. We prefer cosmic drama to terrestrial data, alien possibilities to human realities. This misallocation of attention becomes particularly troubling when you consider the temporal scales involved. Atlas has been traveling for potentially billions of years and will continue its journey for billions more. Our observation window represents an infinitesimal moment in its cosmic story, yet we've devoted extraordinary resources to studying this brief encounter. Climate change operates on human timescales, requiring immediate action. The window for preventing catastrophic warming closes within decades, not geological epochs. Nuclear weapons pose risks that could materialize within minutes, not millions of years. Pandemic threats emerge on timescales, measured in days or weeks, not cosmic cycles. The coordination mechanisms demonstrated during the 3I Atlas investigation prove that humanity possesses institutional capacity for rapid, effective response to global challenges. But this capacity activates only for phenomena that capture public imagination, rather than those posing actual danger to human survival. Observatory networks achieved real-time coordination that would make military commanders envious. Data sharing protocols enabled transparency that exceeds most governmental cooperation. International collaboration proceeded with efficiency that puts diplomatic efforts to shame, all for studying an object that will never affect human welfare. These same mechanisms could address existential threats that operate on relevant timescales. Nuclear proliferation monitoring requires exactly the kind of international coordination that characterized 3I Atlas tracking. Disease surveillance systems need the rapid data sharing that connected observatories worldwide. Climate research demands the sustained collaboration that maintained months of continuous observation. The opportunity cost extends beyond resource allocation to encompass scientific talent and institutional attention. Some of our finest minds spent months analyzing spectroscopic data from a harmless interstellar comet. These same intellectual resources could have advanced climate modeling, pandemic preparedness, or nuclear safety research by decades. The irony becomes almost painful when you consider the technical sophistication applied to 3I Atlas analysis. We can measure chemical ratios in objects traveling at 130,000 miles per hour across interplanetary distances. We can predict trajectories with precision that accounts for relativistic effects and radiation pressure. We can coordinate observations across multiple continents with timing accuracy measured in milliseconds. Yet we struggle to achieve similar precision in monitoring our own planet's atmospheric chemistry. Carbon emission tracking lacks the accuracy we routinely achieve for interstellar visitor spectroscopy. Climate model coordination falls short of the international cooperation that characterized 3I Atlas research. Environmental monitoring systems operate with funding shortfalls that would be unthinkable for space telescope programs. The institutional response to 3I Atlas revealed humanity's remarkable capacity for scientific coordination when motivated by appropriate objectives. The same capabilities could address challenges that threaten civilization on timescales that actually matter. The question is whether we'll choose to apply them to genuine dangers or remain captivated by fascinating distractions. Perhaps the most unsettling realization is that our response to 3I Atlas demonstrates we already possess the tools needed to address existential threats. International cooperation, rapid data sharing, precision measurements, sustained monitoring, all proved achievable when studying a harmless cosmic visitor. These same tools could prevent climate catastrophe, nuclear accidents, or pandemic disasters if applied with similar dedication. The tragedy lies not in lacking capability, but in misallocating attention. We direct our most sophisticated instruments toward objects that pose no threat while ignoring phenomena that could end modern civilization. We coordinate global networks to study ancient chemistry while failing to coordinate responses to contemporary dangers. The psychological satisfaction of cosmic speculation overshadows the urgent necessity of terrestrial problem solving. We prefer grand narratives about alien intelligence to mundane realities about human intelligence failures. We're more interested in cosmic consciousness than planetary consciousness, more captivated by interstellar visitors than atmospheric visitors like greenhouse gases. This preference for fascinating mysteries over boring dangers reflects deeper issues about human motivation and institutional priorities. Cosmic phenomena feel profound and significant in ways that policy documents and statistical projections never can. We're naturally drawn to questions about our place in the universe while remaining resistant to questions about our responsibilities on this planet. The media amplification of cosmic mysteries versus existential risks creates feedback loops that reinforce misplaced priorities. Public attention follows dramatic speculation about alien reconnaissance rather than detailed analysis of climate feedback mechanisms. Political will respond to constituent interest in cosmic visitors rather than constituent need for existential risk mitigation. Yet the technical achievements of the 3I Atlas investigation offer hope alongside frustration. We've proven that international scientific cooperation can achieve remarkable results when focused on clear objectives. The same coordination that tracked an interstellar visitor across months of observation could track atmospheric changes across decades of climate monitoring. The precision that measured chemical ratios in objects traveling at interplanetary velocities could measure emission ratios from human activities with similar accuracy. The real-time data sharing that connected observatories worldwide could connect climate monitoring stations with equivalent effectiveness. The sustained attention that maintained continuous observation of 3I Atlas for months could maintain continuous focus on existential threats for years or decades. The funding that appeared spontaneously for telescope time could support atmospheric monitoring with equal generosity if public priorities shifted appropriately. The infrastructure already exists in many cases. Satellite networks monitor Earth with sophistication that exceeds our observation of interstellar visitors. Ground-based sensors measure atmospheric composition with precision that rivals spectroscopic analysis of distant comets. International institutions possess frameworks for coordination that proved effective during the 3I Atlas campaign. What's missing isn't capability, but motivation. The same psychological factors that made 3I Atlas compelling cosmic drama, mystery, the possibility of contact with alien intelligence, operate against climate change, nuclear risks, or pandemic preparedness. These terrestrial challenges lack narrative appeal despite posing infinitely greater danger to human survival. The solution might require reframing existential threats in ways that activate the same psychological responses that cosmic visitors generate. Climate change represents contact with alien physics operating at planetary scales. Nuclear weapons embody intelligence far beyond human comprehension in their destructive capability. Pandemic diseases demonstrate consciousness-like adaptation and evolution that exceeds human planning. But such reframing risks, trivializing genuine dangers by reducing them to entertainment. The urgency of existential threats demands serious response rather than cosmic drama. The technical capabilities demonstrated during the 3I Atlas investigation should serve practical purposes rather than psychological satisfaction. The choice facing human civilization isn't between cosmic curiosity and terrestrial responsibility. Scientific exploration and existential risk mitigation can coexist when priorities align appropriately. The issue is proportionality, dedicating resources to challenges based on their actual significance for human welfare rather than their appeal to human psychology. I-Atlas will complete its passage through our solar system and disappear into interstellar space according to laws as reliable as mathematics. The visitor poses no threat, requires no further response, and will never return to influence human affairs. Our investigation has generated valuable scientific insights about interstellar chemistry and galactic evolution, knowledge that enriches understanding without addressing urgent human needs. Meanwhile, climate change accelerates according to physics as inexorable as orbital mechanics. Nuclear weapons proliferate according to political dynamics as predictable as gravitational interactions. Pandemic threats emerge according to biological principles as universal as chemical processes. These challenges demand immediate attention and sustained effort from the same institutions and individuals who studied 3I Atlas with such remarkable effectiveness. The worst-case scenario for this ancient visitor isn't alien surveillance, cosmic consciousness, or incomprehensible intelligence. It's human intelligence failure, the possibility that we'll remain so captivated by cosmic mysteries that we ignore terrestrial realities until prevention becomes impossible. The technical capabilities, international cooperation, and sustained attention that characterized our response to 3I Atlas prove that humanity possesses the tools needed to address existential threats. Whether we'll choose to apply these tools to challenges that actually threaten our survival remains the ultimate test of our species' cosmic intelligence. The universe offers no opinion about our priorities, no guidance about our choices, no comfort about our chances. The decision lies entirely with us, and the consequences will determine whether future generations thank us for our wisdom or wonder at our misplaced fascination with harmless visitors, while ignoring preventable dangers. As this cosmic messenger fades into the stellar background, it leaves behind not secrets about alien intelligence, but questions about human intelligence and our capacity to focus remarkable capabilities on challenges that actually matter for our survival among the stars. The silence that follows might be the most important sound we've ever had the opportunity to hear. Not the absence of alien signals, but the quiet recognition that our greatest threats and our greatest opportunities both originate much closer to home than we've been willing to acknowledge. In that recognition lies either our salvation or our downfall, depending on what we choose to do with the extraordinary capabilities we've proven we possess when the stakes feel appropriately cosmic. The universe watches and waits, offering no judgment about our priorities, no assistance with our choices, no guarantee that wisdom will prevail over wonder in time to matter for the species that dared to study the impossible while ignoring the inevitable. The ancient wanderer carries with it the frozen chemistry of distant worlds and the hopes of human scientists who achieved remarkable coordination in service of cosmic curiosity. Whether that same coordination will serve human survival remains the question that could determine everything about our future in a universe that offers infinite mysteries, but only finite time to solve the challenges that actually threaten our existence. The choice is ours, and the clock is ticking, measured not in geological epochs, but in human generations that may run out faster than we realize if we continue prioritizing fascinating possibilities over fundamental necessities. The reality we must confront is that our fascination with 3i Atlas reveals something far more troubling about human nature than any cosmic conspiracy ever could. While we've marshaled unprecedented international cooperation to study a harmless chunk of interstellar ice, we've simultaneously demonstrated our species' remarkable ability to ignore actual existential threats that operate on timescales that actually matter. The coordination achieved during this investigation reads like a masterclass in human potential. Observatory networks spanning continents synchronize their efforts with precision that would make military strategists jealous. Data flowed between institutions that normally guard their findings like state secrets. Scientists who typically compete for resources suddenly shared them with generosity that bordered on the miraculous. Yet this same coordination remains mysteriously absent when addressing challenges that could literally end human civilization within our lifetimes. Climate monitoring receives a fraction of the funding we've devoted to studying 3i Atlas. Nuclear proliferation tracking suffers from cooperation failures that would be unthinkable in astronomical research. Pandemic preparedness systems lack the real-time coordination we achieved effortlessly for observing an object that poses zero threat to human welfare. The technical sophistication applied to 3i Atlas analysis reveals capabilities that should humble us. We measured chemical ratios in an object traveling faster than a rifle bullet across interplanetary distances. We predicted trajectories accounting for relativistic effects and radiation pressure. We coordinated observations across multiple time zones with millisecond precision. These same capabilities could revolutionize our approach to terrestrial challenges. Atmospheric monitoring demands identical precision spectroscopy. Climate modeling requires similar computational coordination. Environmental verification needs the same transparency and data sharing that characterized our astronomical collaboration. The infrastructure already exists in many cases. Satellite networks monitor Earth with sophistication, exceeding our observation of interstellar visitors. Ground stations measure atmospheric composition, with precision rivaling spectroscopic analysis of distant comets. International frameworks possess coordination mechanisms proven effective during the 3i Atlas campaign. What's missing isn't technical capability, but psychological motivation. Our brains evolved to respond to immediate, visible threats moving at human scales. A mysterious visitor from another star system triggers narrative frameworks that feel cosmically significant. Parts per million of atmospheric carbon dioxide activate no such urgency, despite representing infinitely greater danger to our species' survival. The media coverage patterns expose this cognitive mismatch with painful clarity. Speculation about alien reconnaissance generates millions of clicks, while detailed climate analysis struggles to maintain attention beyond initial headlines. We prefer cosmic drama to terrestrial data, alien possibilities to human realities. This misallocation extends beyond resources to encompass our finest scientific minds. Months of intellectual effort analyzing harmless interstellar chemistry could have advanced climate research, pandemic preparedness, or nuclear safety by decades. The opportunity cost measured in human potential staggers the imagination. The temporal scales compound this tragedy. 3I Atlas has traveled for billions of years and will continue its journey for billions more. Our observation window represents an infinitesimal moment in its cosmic story. Meanwhile, climate change operates on human timescales requiring immediate action. Nuclear weapons pose risks materializing within minutes. Pandemic threats emerge within days or weeks. The psychological satisfaction derived from cosmic speculation overshadows urgent necessities of practical problem solving. We're naturally drawn to grand narratives about universal significance, while remaining resistant to mundane responsibilities for planetary stewardship. The appeal of alien intelligence exceeds concern for human intelligence failures. Yet the 3I Atlas investigation offers hope alongside frustration. We've proven that international scientific cooperation achieves remarkable results when motivated appropriately. The same coordination tracking an interstellar visitor could monitor atmospheric changes. The precision measuring interplanetary chemistry could assess terrestrial emissions with equivalent accuracy. The sustained attention maintaining months of continuous observation could focus on existential threats for years or decades. The funding appearing spontaneously for telescope time could support climate monitoring with equal generosity if priorities shifted appropriately. As this ancient wanderer fades into the stellar background, it carries with it perhaps the most important lesson any cosmic visitor could deliver. Not secrets about alien intelligence or warnings of galactic conspiracies, but a mirror reflecting our own remarkable capabilities and troubling priorities. The worst-case scenario for 3I Atlas was never about what it might do to us, but what our response revealed about ourselves. We proved we can achieve extraordinary international cooperation, deploy cutting-edge technology with precision, and sustain global attention for months when something captures our imagination. The question that remains as this visitor disappears forever into the cosmic deep is whether we'll apply these same capabilities to the challenges that actually threaten our survival before it's too late.